So here I am. Let's try to solve some easy LeetCode questions. I took the challenge to complete all the top 100 liked LeetCode this playlist. So let's just start from the easy problem so that we build our confidence, and we will slowly go to the hard questions soon. So let's just try our first problem, which is this majority element problem. Let's just quickly remove this. Okay, so for the majority element problem, see the question: given an array nums of size n, return the majority element. Basically, majority element is an element which occurs n by 2 times at least. For example, here the size of the array is 3, so the majority element will be 3 because it occurs 2 times. It is given that the majority element is there for sure in the input, so we don't have to check for the false case. Okay, so what we can do is we can find a solution by something calling this recursively. Let me show you how. So let's just assume like this is our array. Let's initialize it with something like this. Here our majority element will be 1 because n is here 1 2 3 4 5 6 7 and one occurs, or one occurrence is 4, which is like greater than n by 2. So here we must return the output to be 1 of the function. So what we can do is we can make something call something recursively. Let's say we can divide it into half. It will be divide and conqueror algorithm. We will divide this into 2 halves. One will be this, other will be the other half. 3 1 2 1. Okay, so what we will do, what we will try to do is, when this recursive call returns, we will give the what is the majority element by the left side of things. Let's say here it is 1, so we will return 1. And what we will do here also, we will go back and see here also the majority element is 1, so we will return 1 also from this. And if both matches, like in the left side of recursion is saying that 1 is the majority element, and the right side also is saying that 1 is the majority element, then surely 1 is the majority element, so we will return 1 here also. But say if let's just break it down further and say it will give 1, it will give 2 1, it will go like 3 1, it will go like 2 1. Further breakdown, it will give 3, it will give 1, it will give 2, it will give 1, it will give 2, it will give 1. So now here as it is only one element, we will return it, and as 1 is the majority element here, we will return 1 here. But from this side of things, let's say here it will give return 2, because here the occurrence of 2 is 1 time, so the majority element for this subarray is 2, but for this one it will be 1. So now here the left is saying that the majority element is 2, but the right is saying the majority element is 1. Here is the contradiction part here, so we need to like recalculate the majority element for for this part, because there is ambiguity, like do we have to take care of left subtree or the right one, from whom we which we have to listen. So we will run a for loop to just confirm uh, which is the majority element. Here we can return anything. Let's say here we can return one also and two also. Let me show you. If we return one, so then here the right one is saying one and the left one is saying one, so then there is no ambiguity, so we will return one from this subtree. But if we return the 2 from here, let's say if we return 2 from this, then there is ambiguity. The left side of this is saying 1 is the majority element, but the right side of thing is saying that the 2 is the majority element. So we will run a for loop here and calculate which one is the majority element. So here, after running the for loop, we can easily find that the 1 is the majority element. So this is the general algorithm which we will follow. We will use the divide and conqueror type algorithm, and we will return the answers if the left is saying that the majority is x and the right is also saying that the majority is x. We will return x. If the right is saying that the majority is y and the right is saying that the majority is y, then we have to recalculate it using a for loop. So this will be the general algorithm. Let's just quickly write the code. Let's just make the helper function which will return the answer. Let's just make return helper. We will pass our array, and as you can see in all the steps, we need to pass this helper, like the recursion function name, I am calling it helper. So what we need is the array we needed, and the starting point and the ending point we needed to like define the sub array which we are defining. So let's just quickly do that. For the start, for the whole array, the starting will be 0 and the ending will be nums dot length. So now this function will return the majority element from the whole array, like this, like I am calling this helper function there. Like this whole array, start will be 0 and ending will be n. So I am calling this array, so the helper function recursively will return the answer for the whole array for this. Okay, so now let's just define our helper function, as it is the int data type which we have to return. So we will make a int data structure. We will return int from there, public int helper. First will be array nums, then start and end. Okay, also the ending will be nums.length -1 because of the 0th indexing of the Java arrays. Yeah. So now we have to return the majority element. So let's just store the majority element here, and we will return the majority element at last. Okay. So now we will check our base case first. That is if start is equal end, like for the let me clear this some space. So the base case will be when we reach like after breaking we reach this only one element subarray. For this, the base case will be s equal end. Like here the start will be same and end will be same. So this is the base case, and we have to return the majority element, that is 1. Like if there is single element subarray, the element which is there will be the majority element itself. So we will return that. if start is equal end, we will return nums of start, signifying we have reached the single point. We can return end also, we can return start also, because start is equal to end here, so it does not matter. Now let's say we handle our base case is done. So now uh, what we have to do is like store the output of the what left one is saying and what right one is saying. So let's just define what is the answer for left call, what is the majority element left is saying, and what is the majority element right is saying. We will call this recursively, and the left side of the thing we have to calculate a mid element for that, uh, because we are splitting this into the equal half, so we need middle element to split them into two. So let's just quickly calculate the middle. It will be start plus end by 2. Okay, now start plus end by 2 is defined. So so let's say if the middle is here, we have to include middle for the left side, and we will start from middle plus 1 for the right side. We can do otherwise also, that at the left side of the subarray we will use 0 to mid minus 1 and take middle in the right side. Whichever you will do, it is perfectly fine. So let's just call the array, and then we will be start comma till the middle, and the right side will be from the nums comma mid minus 1 to end. So we have splitted our array into two equal halves. This is dividing part, divide and conquer rule. So now our recursion will take care and give me the answer for the left side, that what will be the answer for the left side of the left. It will return left majority element, and it will return right majority element. Recursion will take care of that. So now if a underscore l is equal to a underscore r, basically signifying that the both of left and right is giving the same answer, that the majority element is x, we will return the x itself. But if they both are giving two different answer, we will have to run our for loop to get the appropriate majority element. So what we can do is to be in a for loop. So the candidate, let's say let me just explain you this real quickly, how we are going to do that. Okay, let me think of an example real quickly. Let's say here 1 1 is there and here 2 1 is there. Now at the dividing rule it will be 1 1, and it will be 1 1, then 1 1, and it will be 2 1 like this, and it will be like this. So here the base case is there, so it will return 1 as the majority element. It will, let me just use the different color for this. At the return step, this will return 1 as the majority element, this one also return 1 as the majority element. It is the base case of our thing, that the start is equal end, we will return the number itself. Then For this it will return 1. Due to the similar reasons, it will return 2 for the part. As here in the left side of the thing, it is returning 1 as the left and right as also giving the 1 as the majority element. We will do not calculate anything and we will return the 1 as it is, that the both is saying this is the majority element. So for the this part of the sub array, 1 is the majority element for that, so we will return that. Now the tricky part arrives for the secondary. For the secondary, which is the 2 1 array, which goes something like this, 2 1. So as you have seen that it returned 2 as the majority element and it returned 1 as the majority element. Now here what we have to do is we can return as, see this 2 and 1, there is still an ambiguity which we have to return. In our recursion we can return anything, like 2 we can also return, 1 we can also return. Let's suppose we return 1, let's suppose we return 2. Now the left was saying that the 1 was the majority and the right is saying that the 2 is majority. So now we have to recalculate using the for loop. We will make a counter, let's say 0. If this counter is positive, we will listen to 1, and if this counter goes to negative, we will listen to 2. Basically these two are candidate only. The majority element will not be something else other than this 1 and 2, because left is saying that the x is majority element and right is saying the y is majority element, then there is no chance that some another number z will be the majority element. That is impossible. So our answer lies whether the answer is 1 or 2. So we will make a counter, positive direction signifying we will favor 1 and the negative direction signifying we will favor the negative part. So what we will do is we will run our for loop. As we have gone to 1, we will increase our counter, as positive direction means we have 1. We will go to next. Here also it is 1, so we will increase our counter to 2, like we will again increase it. Then we have encountered a 2, this means a negative direction, we will decrease our counter to again 1. Now we again encountered a 1, which signifying that we have got our majority element c is equal to 3, which is positive in direction. Sorry, c is equal to, c will be 2 for this case, and as it is positive, which means 1 is the majority element. So let's just make a for loop quickly. Our for loop will start from start of the array, which the start variable we define, and it will go to the end. We will go I plus plus. Let's just make a counter, int counter is equal to 0, basically signifying the positive direction we will favor the left majority element, and the negative direction signifying we will favor the right side of the thing. Let's go. If nums of I is equal a underscore l, basically the left one is satisfying that the a underscore l in this case is 1, and the nums of I, nums of 0 is also 1, so we will increase the counter. So we will increase the counter. In the other case we will decrease the counter, basically signifying that the number which we got. Now let's just make a case here, that else if we got nums of I equal a underscore r, basically favor for the right majority element, we will decrease the thing, and we will check that who wins, basically positive direction wins or the negative direction win. Let's say if our c is positive, that means the majority elements called by the left side wins over the right, so we will return the left majority element as our whole majority element. If c is greater than 0, we will return a underscore l, else we will return the right one. Okay, so let's just quickly run this and check is our solution working. Okay, there is some error here. Okay, so there is no need for this thing because we returned the majority element in the loop itself only, so there is no need to return it otherwise. Okay, so the recursion is not working properly. The start will be here, it will be mid. Okay, it will be mid plus 1 because till mid we have done, so it will be mid plus 1, not mid minus 1. Yup, so this worked and passed all the test cases. It was a tricky question also. It tells you the basic of divide and conquer question. So it is quite good start for complex algorithm because here we have the recursion also, and we have this logic of bipartite kind of thing where we define a counter and favors one over other by counting the occurrences and decreasing if the other occurs. So it was a quite decent example because it included recursion and handling of base case and all those things. So we have done the majority element question. Now let's just quickly solve this single number problem. So according to the problem, the question is stating that in an array every element will be occurring twice except the one element which we have to return. So for example, in this nums array, 1 is repeating 2 times, 2 is repeating 2 times, but the 4 is occurring only 1 time, so we have to return the 4. Similarly, in this array, the 2 is occurring 2 times, but only 1 is here that is occurring only 1 time, so we have to return this 1. So the brute force approach for this question can be something like this will be brute force. We can maintain a frequency map. We can make a frequency map which will store the integer. First integer will be the value and the second one will be the frequency. Let's say if the 2 is occurring twice, we can store that into our map. Let's say like we can store something like 2 occurring 1 time, then let's say a second time a 2 occurs, so we can update this to like 2 occurred 2 times, and similarly 1 occurred 1 time. So we can make this map kind of data structure, and then after making this map we can iterate it and we can find where the value is 1, and we will return the corresponding key to that. So for this kind of approach, it will be order of 2n basically, because first we will run the for loop and fill our hash map, which will be order of n time complexity. Then we will search in this map, so that will be order of n time complexity. Also the space complexity will also be order of n because we are making a hash map. But can we do something better? So we can do something better. The brute force can be done easily by you guys. It is just for loop and making a hash map and storing the frequency of the value. so that can be occurred, but the key concept here is the XOR operation. So basically XOR operation is something like, let's say we let's say let me make a hexor table. So let's say A B, if we do A XOR B, so it is something like, let's say 0 0 1 1 0 1 0 1. So if we do XOR of two same bit, then the answer will be 0, and if the bit is different, then the answer will be 1. As here the XOR bit is 1 and 1, so the XOR of those will be 0. Basically it is exclusive OR. So we have to like have only one true value and the other has to be 0, then only it will return the 1. Otherwise if the value is same, it will return 0, for example in this case. So how this can be useful for solving this kind of question? Actually in this question every number is appearing twice except 1. So let me replicate this XOR operation in decimal setting. The table method was for the binary setting. Let's say a number is 5, let's say A is 5, and let's say B is again 5. So the if we do A XOR B in decimal, what happens is that 5 is converted into its binary corresponding, which will be something like this and this. Now if we do XOR of these two numbers, let's say XOR of these two numbers, you can see that the 1 and 1 is same, so we will do bitwise XOR. So the bitwise XOR of 1 and 1 will be 0, 0 and 0 will be again 0, and 1 and 1 again will be 0. So a key inside here is that if the two numbers are same, let's say here A XOR B, and this A and B are same, then same as the binary, when 1 and 1 was same, the answer was 0. Here also if the in the decimal also if they are same, their XOR will be 0. Let's say here 5 XOR 5 will be 0 because of this condition here. Or you can take any binary operator, any decimal number, let's say 10 or 20 or 100 also, whatever the number will be here, the same number will be here, and if we do bitwise XOR of those, the answer will always be 0. So now we are arriving somewhere. The theory is clear to you guys. Now let me give you one more insight here. So what we can do is, let's say the our array is say 5 5 2 2 and 4. So if we do XOR of these, you can think of like that this 5 and this 5 will cancel out each other, and this 2 and this 2 will cancel out each other. This will return 0, this will return 0, and this 4 will only left, and if we do 4 XOR with these guys, the answer will be 4. So now you can understand that these XOR can cancel the same element that is occurring, that but the key here is that it has to be twice. Let me more elaborate it so that it is completely clear to you all. So why it is like that? If we do XOR, the answer will be correct. The main thing is that here, same as addition operation, which is associative and commutative, we can like do A plus C plus D. We can do something like, we can first take A and C, then add these two to D, or we can also do something like first we add C plus D and then the result will be added to A. Basically this is associativity property which we can do in addition. Similarly we can do this same property here XOR wise also. So if the array is something like different, let's say the array is like this, if the array is something like this and we do XOR of all the numbers, what can happen is, due to commutative and associativity property, we can rearrange these numbers and we can have something like this. Basically what I have done was, we have to do this, but due to this associativity and commutative property, we can convert the upper sequence into the below sequence, because we can, let's say, replace these two, we can commutate, or like basically 2 plus 4 or 4 plus 2 is exactly same, so we can do this kind of rearranging. And now you can see all the repeated ones will result in 0 and only 4 will be left here. So this is the core idea. Here. I hope this is completely understand by you guys. Okay. So let me just quickly write the code for this. So we have to return an integer, that single element that is occurring. Let's give it answer. We will return this answer. We will run our for loop. And we will just XOR it in our answer. So this this symbol is for the XOR operation in Java. So this should work. Yeah. So now we have done the two questions. Let's just quickly move to the move zeros question. So for this question, we have given the array nums. What we have to do is shift all these occurrences of 0 to the end of this array and make something like this. Here the key catch is that we can't use another array or space complexity kind of thing. Basically array list, we can't use another array or something. If this restriction was not there, this question was very trivial to solve. What we can do is make an array, another array, make two arrays. For example, first one will be the nums only and the other one will be the array list of, say, constants. So what we can do is like push the occurrences of non-zero numbers. Let's say if the number is 0, we will skip that. If the number is 1, we will add to the array list. Then this 0, we will skip that. Then this 3, we will add that into the array, and then this 12, we will add that to our array. After this first for loop, our array list will be something like 1, 3 and 12. So what we can do was that calculate the size, basically calculate the size of that calculated array, basically the size of this one. What was the array? 1 0 3 13. So this the size is 3 actually here. So what we can do was, in nums, we will run the for loop from I equals 0 to this 3, and we will fill this nums of I equal to this array list. Let's say we have defined this array like this. We will get this, we will like initialize and get these one by one, and the remaining one, after this, our array will be something like this: 1 3 12, and what was the other? 3 12. So after this was our array, and we can fill these rest of numbers with 0, and we will return this nums. So if we had an option to make another array, we can do this simply by this. but here the question is different. So we have to do a workaround here. We have to do something in place kind of thing, so that we don't have to define another array or so. We have to use only this int nums array only. So let's just quickly copy the question. So the question is 0 1 0 3 12. 0 1 0 3 12. So what we can do is here, we can use a two pointer concept. This is a question of two pointers. Let's say the size of this is 5. So let's just make a size of 5. Let's initialize L to be 0 and R to be 0. Initially everything is at the start position. So what we can do here is that whenever we encounter a 0, let's say in start we encountered a 0, what we can do is we can swap this 0 with the first non-zero number we find. Let's say if we found a 0, then we will store its value in L and we will move further, and as soon as we found something non-zero, we will make it equal to R. We will swap these two. By doing so, what will happen is that 0 and 1 will change their positions. And by doing again and again this thing, by replacing non-zero at the left side and the 0 at the right side, at the end of the things we can have something like, here it will be all non-zero numbers and here every number will be a 0. So let's just quickly do a dry run for this kind of approach. Initially L will be 0 and R will be 0. So we can make a while loop. We will make a while loop, and while will be from R till R less than n, basically our constraint where n is equal to 5 for this specific question. N is the size of the array. R can't go further than that. So it is quite simple and self-explanatory. So now what we have to do is make see our what is the, we have 0th number or not. Let's say if nums of L is equal 0. Now this is the case we have find that the nums of L is 0. So what we can do here is we will run again while loop. I will explain this in a bit again. While R is less than n again, what we will do is it will be something more. While R is less than n and nums of R is equal 0. We will do R plus plus, and after this while loop we will find something like either the R has gone out of the bounds or the nums of R is a non-zero number. Basically we have to find a non-zero number and a 0 number to replace. We have found the 0th number which is at L, and basically the other while loop is finding the number that is non-zero number. So this while loop will either break when R is equal to n, or nums of R is equal to a non-zero number. Basically we have found that R where we will swap our L with. So after this while loop we will quickly check that if our R is less than n, basically this is not the first case. So the while loop does not break because of the R less than n condition. We will do this. Now we have guaranteed that the nums of R is not equal to 0 in this case. Now we will have to perform a swapping. So for the swapping what we will do is basically we will swap simply as make a swap function, or swapping is very easy to do. We will swap the lth term and the rth term. We will swap this, and after the swapping we will increase our l plus plus, because the lth work has been done. So we will increase l plus plus, and we will also increase r plus plus. And for this condition we have to see that either the r is less than n or l is less than n. We can find that, and in the code itself if there is some error we will try some trial and errors to encounter this. So let me just quickly write the code to see either this code is working or not. So let's just quickly make our two pointers. Okay, now let's make a outer while loop condition. Let's just quickly define the size of the array. Let's say if nums of L is equal 0, we have found the left side of the thing. Now we will find the right hand side of the things. Less than n and nums of r is equal 0. Basically this while loop will run and handle all the zeroth case. Basically this inner while loop will take care of something like let's say 0 0 0 1. Now let's say our left is at here and r is also at the start. So this will do something like until we found a non-zero number, it will run, it will do something like this, and it will find the first known occurrence of that, and after that we will increase the l plus plus after the shifting. Yes, the code should work and I believe is correct. If some small errors occur we will debug that. Okay, we will do r plus plus here, and after this while loop we will do if r is less than n, we will do swapping. Here our swapping will occur, so let's define int temp to be equal to nums of l. We will swap it. Basically we don't even need to have a temporary variable because we know that the nums of l is equal to 0, so we will just make nums of r to be equal to 0 only. But to be more clearer, let's do this way, as everyone is comfortable in this way only. To be we have store nums of l, so we will swap it with the rth term, the first non-negative part we have swapped it. So now nums of r will be equal to 0. In that case it will be temporary variable which we have defined here. Okay, so this if condition is also done. Now we just need to do l plus plus, and I am thinking where to do that. Okay, so r will increase and find the r increment is correct there in the inner while loop. Here also the l will definitely increase, so let's just do increase it. Let's just run this and see how the things go. Oh, actually maybe this is the correct code itself only. Oh, there is some error here, so I believe here it will be l. Just quickly run this and check. Now the previous one is also lagging. So let's just try to, like, if this, then let's just do r++ only. Okay, so something is passing. Let's just take this example and see why our code is failing. 101 it is failing for. Okay, let's just try run our code for this case, why this is happening. The case is 101. Okay, so initially L is at here and R is also at here. So what we are doing is, if nums of L is equal to 0, which is not the case here, we are going and increasing to R and making it, which is not the case here. We will make R to go here, and after that here, and this will swap with L hour. So here actually it is not R++ but L++, and here it should be L less than. Why this kind of issues are coming? Just in this case, if we do R++ only, nah. We can't just increase our L like that. We have to store L somewhere, so L can't increase. Okay, here it should be R only. Okay, maybe here with L we should also increase R also, and we can comment this out. Some error is coming. Okay, so if nums of L is not equal to 0, then that thing is already at the start, so we don't need to care about that. So what we can do is just simply go L++ for that. The zeroth are causing the problem, not the lth one. So I don't think this if condition is not there. Okay, now this is accepted, but let me just quickly see why our initial condition was failing for that. Our L will be at 0 at the start, and say if okay, so we are increasing L and R both in that case. Okay, okay, so basically the issue was this if condition here. This if condition should not be here, rest the code was working. Okay, let's just quickly go to some another question and boost our confidence again. That question literally just kills my confidence because it was the easy question altogether, and I fumbled that question. So let's just quickly do this valid parenthesis question. I believe I can solve this easily, but let's just. Okay, now the site is lagging. Okay, okay. So let's just remove this. Okay. So the valid parenthesis question is a very standard question, so I should be able to solve this easily. Mm, Here we have given a string s containing just the characters of all the types of parenthesis combination that can be possible can occur in the string. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. So for this kind of question, the stack will be used basically. Let me tell you about the stack data structure quickly. So basically we will push all the brackets which have the left side of thing in curvy side of thing. We will push all these things on the stack, and we will remove from the stack when we encounter right side of things. We will remove if we encounter a right kind of thing, and if there is some mismatch here, we will return false, else we will return true in this kind of question. So let's just try to solve this question. Let's make our stack first. Stack, as we have to store a character of these brackets, so we will make a character data type here. Okay, now we will iterate in the string. We will go to all the characters which can be possible. Let's just define the size of the string. We will go to all the characters in the string, while let's say we will make our iterator int I equal to 0, which will go from 0 to all the way up to the end. Okay, so the iterator is sent, and we have to return a boolean. If the stack is empty, we will return false. No, we will return true, and if the stack has something left, we will return false. So let's just quickly write the end case also. If empty, if the stack is empty, we will return true. Basically we handled all the brackets, and all the brackets easily got removed and found its pair, so we will return true. Will return false. So we will push all the left open brackets into the stack if we found those. So if, let's define the character. Now if the char is equal open round bracket, or char is open curly bracket, or char is open square bracket. we will push that into the stack. Okay. Now what we will do is we will if every character is something like this, the curly bracket, I'm saying this case, let's say the s is something like this and this. In this case the stack will have all these in order, and as we don't have any corresponding occurrences of the right closing of these, the stack will remain of some size. Here the size will be 4, so we will return false. So what we will do is we will now if we encountered a square round bracket here, we will we will check the stack's latest member. If these two matches, we will remove. If there is some mismatch, we will return false there itself. So we will check, let's say if our C is equal this kind of bracket, and our st dot peak is not equal to its corresponding left side, we will return false. So basically it is saying something like if we encountered this bracket in somewhere, and if the previous to this bracket is something like this, then this is not a valid case, and we will return false. Basically the equation or the string is not valid. It is only valid when if we encountered this and the stack has the latest member this, then only it is valid. So we are taking the negative case here. Similarly, all the three brackets share the same or similar kind of conditions. So here it will be curly bracket, and here it will be square bracket. Here it will be curly bracket, and here it will be square bracket. So now we have handled all the false cases, and at last if we found a true case, when we found a matching pair of these two, we will remove these two from the stack. Basically we will remove this from the stack, and we will move our I to the next position. So at last, if we found if everything is okay, we will do st dot remove the latest entry from the stack, and we will move to the next index. So this should work. Let's just run. st dot remove is not a correct statement, so for the stack the commands are stack dot pop and push. So let's just do pop. Empty stack exceptions is occurring. Okay, so here there is one condition also, that if the stack is empty itself in this case, then surely it is a false case. Basically it is saying that we have encountered a basically it is saying that we have encountered something like this, but here the stack is empty, here there is nothing at all. So it is clearly that this can't be at the starting of some valid parenthesis sequence, so we will return false here also. So we will just handle this case also. Here we will make a OR statement to handle that. that if the C is this, if C is this, oh okay, let's just make this, if C is this, and st dot size is equal 0, basically size is 0, then we will return false itself, that there is no element before to look. So this is the case. Let's just copy this. Here it will be curly bracket, here it will be square bracket. Now let's just run. I hope this should work. Okay, there is some error coming. If the stack is empty, we will return true. Else we will return false. Okay. Maybe I need to like specify how I am making this conditioning. Basically this was the condition originally that we have discussed. Basically I'm specifying what we have what you have to do first. These all cases should be else if condition. Else okay, now this should work. Basically I was doing some like, let me show you what I was doing wrong. Yeah, so this is how this code should look, as all the test cases have also passed. Actually what was the issue happening was that what was the issue with my code was that when I was adding these things into the stack, due to the st.pop command, they were removing side by side also, so our stack was becoming empty again and again. So we have to remove only when we have found the corresponding pair to this, then only we have to remove. We don't have to remove after this. Like if we found this, we don't have to remove anything. When we found this, then we have to remove this and this. So this is how it should look. So now just quickly try to solve all the linked list questions of this top 100 liked LeetCode playlist. We will try to solve all these 5 questions quickly. So let's just start with the first question. This is merge two sorted lists. So what we have given is the head of the two sorted linked list. We have to merge those linked list and return the sorted merged linked list head. So it is something like we will be giving the head of the first sorted linked list and the head of the second sorted linked list. We have to compare all the elements and we have to return the merge head of the linked list, sorted linked list. So for this kind of question, I hope you know the merge sort technique. There in the merge function, which we write a merge sort, in that function when we compare and write the logic of the sorted kind of array, the merge code, it is kind of similar to that. Here one thing is given to us, that the linked lists are already sorted. So half of the work is already done by them, so we just need to sort them. So to sort them, let's just quickly write the core logic here. So we will be given, okay, 1 to 4, and the second one is 1 3 4. It is like this. We will given head 1 and head 2. So what we have to do is we will compare these nodes one by one. We will first look this and this, compare both of these. As these both are equal, it does not matter which way you go next. Let's say we go to the next node here. If we go to the next node here, now we will compare this and this. As it is clearly 1 is less than 2, so now the 1 will go, so we will go to 1, and now we will compare this 3 to 2. Clearly 2 is less than 3, so we will go here, and in the same fashion we will write the code also. Let me show you how we can write that code. So our outer loop will be something like, while h1 is not equal to null and h2 is not equal to null, while both of them are something, we will run our loop, and if we reach the end of, anytime we will reach the end of any linked list, we will stop there and we will copy all the things which is there in the other linked list directly, as there is no one to compare to. So we will just quickly append all the remaining nodes to the end of the our calculated linked list. So this will be our outer loop, while loop. Okay, so here, if now we will compare these two heads, if h1 dot value is less than equal to h2 dot value, basically h1 value is less than h2 value, so now we have to put h1 node into our resulted sorted merged linked list. So what we will do now here, in this case we need to first put the h1 node here. So what we will do is, in our current we will make our answer linked list head. What we will do is, we will do current head dot next, we will make it to h11, and as h1 dot value is already done, we will move to the next, or we will like shift this h1 to the next node of the h1, as this one is already put into the answer linked list. So what we will do is, h1 dot h1 is equal to h1 dot next. Similarly, for the else if case, if the other thing is true, we will do current head. Now we will take the other side of the thing is equal to h2, and the h2 will move to the next h2 dot next, and at the end of the things we will move our current also to the next. We will move our current to current dot next, signifying that our merge sorted has moved one step ahead. After that, after that, when this while loops end, basically whenever this while loop end, this means that some linked list which was given to us, let's say this one is A, this one is B, any one of them has been completed, the size have reached its limits. Let's say for example, A is the size of, let's say, consisting only of two nodes, let's say 1 and 3, and B was something like consisting of so many nodes, let's say like this. So now when this while loop end, it means that h1 or h2 has gone to null, which means in this case our A will go to the null. So when this happens, we just need to copy all the remaining nodes of our B linked list into the end of the current linked list which we are calculating. We will add them here, something like this. The current one will already, which we calculated by this while loop logic, we will connect its head to this, and we will return this head here. Okay, let's try to write this logic, and I will explain side by side what I mean by this. Firstly, we need to make our returned linked list which we will return at the end. So let's just call it answer. And for the traversal part of things, let me make a temporary variable to do the traversal. Let's just put it into the start of the answer. Also, I don't want to write all of these, so let's just call them head1 and head2. Now our while loop logic will occur here, that the while h1 is not equal to null and h2 is not equal to null, then only run this loop. So let's just write that while h1 is not equal to null and h2 is not equal to null, then only this while loop will run. Now we will compare the values of h1 and h2. Let's say if h1 dot value is less than equal to h2 dot value, what we will do is, as h1 is smaller, so we will add that h1 node to our sorted, like the answer, and we will move to, as this one is already added, we will move to the next node of list A. Let me show you what I mean by that. So what we will do is, we will do T will become our h1 and h1 will become h1 dot next. Basically this one is already calculated, so we move to the second, and this, for the traversal, we are making this T kind of thing. Okay, and for the else part, basically it is similar kind of code, with T being to the h2, and now h2 will move to the next. After this if else condition, now we will move our traversal to the next, signifying that we have already added this 1 or this 3 to the linked list already. Now when this while loop will end, as I discussed, this case will be something like this, that we have to copy all the remaining part of the things. So now we will only have two cases, that either h1 has ended or h2 has ended. So let's say if h1 is ended, let's say if h1 is equal null. So if h1 is ended, what we will do is we will copy all the remaining h2 into the current one. So what we will do is we will just simply put t equals h2, and in the else part, for the other thing, let me just write the if part only here. That if h2 is equal null, we will write t equal h1. And let me just debug it slightly here to do something like this. And at last we will return our answer. I hope this works. Okay, so I used wrong wording here. It should be list node. There is some error occurring. So it is list node only, and we have assigned it to also. So here basically the issue was that in answer we will provide the next one, so we will not directly assign our traversal one directly to the h1. We will use the next thing to assign that the next one is our h2. Now this should run properly. Yeah, let's just quickly submit this and check our solution. So yes, it beats 100% people. So yeah, this is correct solution. Let's just move to the next problem. which is linked list cycle. Yeah. So for the linked list cycle problem, let me tell you the problem statement of this question. So the question is stating that we have to return true if there is cycle, else we have to return false. So if in a linked list we have a cycle, we will return true, otherwise we will return false. So how we can find this? So let's just quickly copy this test case 320 minus 4. So it is something like 320 minus 4, and it is something like this, and this 4 is going back to 2. So it is like this. So how we can solve this kind of problem? So this kind of problem require a knowledge of two pointer, a fast and a slow pointer kind of problem. How we can solve is, we will, as this head is given to us, we will initialize two list nodes, a slow pointer and a fast pointer. Our slow pointer will move only one step at a time. Slow one go like 3, then 2, then 0, then minus 4, then it will go to 2, because this node 4 dot next is pointing to 2, so it will go to 2, and it will redo this loop again and again. And our fast pointer will skip one turn at a time. So basically our fast pointer will go like 3, then it will skip 2, it will directly go to 0, then it will directly go to 2. And after that 2, it will directly go to 4, then it will go to 2, then it will go to 4, then it will go to 2, then it will go to 4. Basically it will get stuck into the cycle. As you can clearly see, in a slow pointer kind of thing, we are going like this, and in a fast pointer we are going like this. But in any case, let's say if f becomes equal to s, which is signifying that fast becomes equal to s, this should not happen in a normal setting. This will occur only in a cycle setting. Let me tell you why this is so. Because our fast is moving two steps at a time, if there is no cycle in a linked list, our fast pointer will move like this. It will move very quickly and will move faster than our slow pointer. So there is no point that these two become equal at any step, because our slow pointer will move very slowly, and when our slow pointer reaches some point, then our fast pointer will move more further and further away from our slow pointer. So this fast is equal to s will only occur if there exists a cycle here. Otherwise it is impossible that fast become equal to slow. Basically you can think of like, let's say if a number are like this, it is a number line. If this is something like this, and our fast is going two step at a time, that means it is going from 1 to 3, then to 5, then to 7, then to 9, and our slow pointer is going like 1, then 2, then 3, then 4, then 5. It is impossible that fast pointer become equal to slow pointer if there is linear kind of traversal going on. Fast will only become equal to s when there is some cycle is involved. That means the fast pointer, somehow the fast pointer somehow got back to the previous of the slow, then only this fast is equal s can occur. And also this fast and s can occur at the start when we will initialize that f equal s equal head at the start, which is very trivial case. We will move next and do handle that case. So let me just quickly write the code so that you get more idea of what I am talking about. We will make two pointer list node fast pointer, which will be at start will be at head, and our slow pointer, which will also be at head at the start. Now what we will do is while, so it is clear case that fast is moving two step at a time, so it can never be the case that our fast become null and slow is still traveling. This can happen, but it can never happen that the fast is traveling and our slow become null. This can never happen, because if we reach null, the faster pointer will reach null sooner, so our condition will revolve around the faster pointer. While faster is not equal to null, and as it will move two step at a time, we have to care for the error also, that the next fast dot next should also not become null, because if that become null, then where it will travel. Okay, so this is handling of the two step case. uh, Here in the while loop, we will write a condition that if f is equal s, we found the cycle, so we will return true. So the true statement will be handled in the while itself. So now if the while loops break, or let's say the f ended to some null kind of thing, we will return false. Otherwise, if f become equal to s, we will return true. Now we will traverse our pointers. Fast will move two step at a time, and slow will move one step at a time. This should work, this should run. Okay, so this is running and this code submitted. Okay, so now this question is done. Now let's just move to the next question and quickly try to solve these three questions also. Then all the linked list questions that are easy will be solved in our playlist. So let's just see this problem. Okay, so this problem is again a quite difficult and a challenging problem when I first encountered it. Given the heads of two singly linked lists, head A and head B, we have to return the node at which two linked lists intersect. If the two linked lists have no intersection at all, we will return null. So for this, we have to return the C1, and if those do not intersect, we have to return null. Here we will return 2, I believe. Yep. and here we will return 8. So we have to return the junction point here. So how we can do this? Again, this is a slow and a fast pointer concept. What we can do is calculate the lengths of linked list A and linked list B. After calculating the distances of those, we can work around those and subtract the difference between them, and then we can go one step at a time to check if those A and B become equal or not. Let me show you what I mean by that. Let's just quickly write the given thing here. 1 2 3, let's say 11 12, and something like this is given to us. Okay, we will be given this head and we will given this head. So first we will calculate the lengths of these things. What is the length of this and what is the length of this? We will calculate them and we will store them. Calculating these distances is very easy. We will just traverse until we reach null. We will calculate those. So let's just see here. It is 1 2 3 4 5 5 for L1 and 5 for the L2, and then we will calculate the difference between them. It will be 5 minus 5, that will be equal to 0. As the distance is 0, we will start our pointer from here and here, and we will go one step at a time. We will increase this pointer to here and here. Then we will compare, are these two equal? No, they are not equal. So we will continue our loop and go to the next iteration. We will go to this and this. We will check is our A and B are equal. Yes, they are equal. If they are equal, we will return true, that we found a intersection, and we can return just A or B, whatever we are traveling with. Okay, so why this difference kind of thing is happening? As in this case, both of the length were 5 same. This distance does not make any sense, but let me show you some different example where this distance will be very significant. So let's just say this is the case where it is something like this. It is something like this. For this case, yep. Now for this L1 length 1 will be 1 2 3 4 5 6 7 8 8. So it will be 8. Now if we try to do that one step at a time type kind of thing, we will check that 1 okay, 11 is not equal to 1. Basically A is not equal to B. We will move to next. Compare 12 and 2 are not equal and they are not the same node, so we will go to the next. We will go to 3, we will go to 4. No, this 3 is not equal to 4, and the 4 and 3 node are also different. So here you can see that because of this difference between the length of these two, we somehow missed this junction point. So we need to normalize the starting of these two so that we can compare one by one at a time, and we can be sure that we reach this junction point at the same time. For that we need to do a difference. Let's say here difference will be 3. So what we will do is we will go to 3 step ahead of the longer substring. So what I mean by that is as the difference comes out to be 3, as the difference come out to be 3, we will move 3 steps ahead. 1 step, 2 step, 3 step. Now if we compare them one by one again, that junction point will come exactly where we wanted. See, if we start from here, 5 is not equal to 11, we will move to the next. 6 is not equal to 12, we will move ahead. Here 3 is equal to 3, so we will stop and we will return this 3. Basically this normalization has to be done to the longer linked list so that our starting point becomes comparable and the junction point become feasible to our calculations. Okay, so let's just quickly write the code for this problem. Okay, so the code will be something like, let me think of that. First let's just reduce these two heads so that these two does not become our headache. So firstly we have to calculate the lengths of these linked lists, so we will make L1 which will be equal to 0 and L2 which will be equal to 0. We have made these two variables where we will store the lengths of our linked list. Now we will store the wait a minute. Now we will traverse and calculate our L1 and L2 while okay, first we will store our head to some variable so that we can travel that variable everywhere. Okay, while t1 is not equal to null, what we will do is we will increase our L1 and we will move to the next thing, next node. We will move to the next node. Let's just check is it calculating properly. Let's just print the L1 and check is it outputting the correct variable or not. For now let's just return anything. Let's just say return and for question of this 41845 our L1 should print 1 2 3 4 5 5. So yes, our L1 is getting calculated correctly. So let's just quickly calculate the L2 also with the same logic. Now we will increase L2 and we will traverse in T2. So now L1 and L2 are the lengths which got correctly identified by this logic. Now we will make a difference variable which will store the maximum. Basically it can be the case that the L1 become 5 and L2 becomes 8, so we have to do 8 minus 5, not 5 minus 8, because that will be out of the bounds. So let's just make it absolute. That will take care of those kinds of things. That means 5 minus 8 will become 3 only in this case. Okay, now we have to traversal x amount of time, this d amount of time in the longer length linked list. Basically what I mean by that is in the longer linked list, let's say here the longer linked list is this and the difference between them will be 1. Basically 1 2 3 4 5, L1 is 5 here and L2 2 is 1 2 3 4 5 6 here, the difference is 1. So we have to normalize the longer one by running a for loop and traversing it to d times, and here the d is 1, so we will move one step ahead and we will normalize it. Now the starting point for the both linked list is same, so now we can compare apples to apples, something like this. Okay, so let's just check which one is longer. If L1 is greater than L2, if L1 is longer than L2, we have to do for loop for L1. Basically list A was of the bigger size, so we have to normalize that. So what we will do is, for firstly our T1 which has gotten to the null, we will make it back to the head of the first one, which we can do in the start also. So our T1 is back to the head A and our T2 is back at the head B. Okay, now if L1 is greater than L2, we have to do for loop till D. So for int I equals 0 to I less than D, we will do I plus plus. Basically we will loop, and to normalize it, we will just move the pointer to ahead so that the starting point becomes same. So we will do T1 becomes T1 dot next. Now the starting is same. In the else case, we will do the same code but for the second linked list. Now by using this for loops, we have the starting point to be same. For example, in this case, this else condition will run because L2 is greater than L1, so this else condition will run, and when this else condition will run, the D will be 1. So what we will do is, we have moved our T2 which was starting at here to here. Now we are comparing this to this, then this to this, and at whatever step that T1 become equal to T2, we will return that junction point. While T1 is not equal to null and T2 is not equal to null, what we will do is, if T1 is equal T2, we have found the junction point, so we will return T1. Else we will just move to the next step. Next node basically. Okay, so at last, if there is no intersection at all, we have to return the null. So in the code, where is the code? In the code, if there is no intersection at all, we have to return null. Yes, so now this is correct. So this question has been also solved. Now let's just try to solve this fourth question of the problem. Now we will try to solve this question. Basically reverse a linked list. We will be given the head of a single linked list and we have to reverse it. So to this is a classic question of linked list, basically reversing a linked list. So the algorithm is quite standard, and it is good to know this algorithm because too many questions solve from this algorithm alone. So let me show you how it is solved. So basically, here we will be given a linked list. Let's say something like this. What we have to do is we have to reverse it. We have to do something like this. Reverse, reverse, reverse. And we will be given the head of this linked list, and we have to return this new head of the reverse linked list. So how we can approach this question? It is done via a recursion. So let me show you how this can be done. So in recursion we can simply think of it like, let's say we will make a function which will return the reverse linked list. Basically we will make a reverse function which will return our list node, basically list node, the new list node which will be the reverse of the original linked list. So the input will be the head, which is the original linked list we have. So input will be the original head. This will be the original head. We can think of this function as that it will reverse automatically the linked list. Basically, we recursion will take care of this by itself. What I mean by is that, let's say, focus on only on this thing. If we pass two here, like two node here, what we can accept this function will return is something like this. It will return the reverse of this, something like this, and the pointer head will be here. So what we have will be something like this, and we will get this as a result of the function reverse. So we can think of this is that our recursion will handle this automatically. Basically we have to take care, and we have to reverse only this step only here. So how we can do that? Okay, so our original head will be at here. As you can see that we have to reverse this edge over here. Basically we have to reverse this edge over here. So how we can reverse this? So we have this head here. What we can do is we can call make h dot next, which will be 2. H dot next will be 2 dot next, meaning its next thing. We will point that to head. So I hope this is clear that currently the dot next, basically the next of this 2 node, is pointing to null. So we are making writing this statement so that its next points to our original head. So this is one statement. Now we have to remove this edge of 1 to 2 edge that we have. So to remove that edge, what we can do is okay, so to remove that edge we can just point h dot next to null. In that way this edge will be gone, basically this edge will be gone, and now we just have to return our new head. Basically we have to return the starting of this now, so we will return new head only, we will not touch that. So basically this algorithm is all that there is. Base case will be something like, let's say there is base case. So the base case will be when your uh, node approaches to null. Uh, basically when h dot next is equal to null. If that is the case, we will simply return h, basically signifying if there is nothing at the next, this is our main head, new head. So we will return this head, and this will signify that this is the new head of the linked list that we wanted. So let me just write the code and see even if this works or not. Okay. Okay, so the code is something like, let's just start quickly write the base case, that if head is equal null, we will just return null. This is the literally trivial case, base case, so this is nothing to be explained of. Return head only, we can return the null. Now the real base case which we have, that if the head dot next is empty, is null, we will return head only. Basically this is handling the case when we only have a single node. If we have the single node, its reverse will only be this only, so we will just return this head only. This will be our new head. So I hope you get what I'm saying. So we will return this head as a new head, and now what we have to do is we will store the new head, returned new head, in a some variable. So now this function will return automatically the reverse linked list head, the new head, and will store this into the new head. So now what has been already done is, so we are calling the function for this part, and we are storing new head that is equal to 4 in this n underscore h variable. So now we have gotten this, and now we just have to like change the edges of these by this this code here. So now let's just quickly write that. It will be something like h dot basically head dot next is equal to head, and now we just need to point head dot next to null. Yep, and we will return our new head as the final answer. Okay, there is some error occurring. Maybe this is the not required at all. List node, reverse list head. What is the issue? Okay, we have to call head dot next basically. Yep, so the code is submitting, every test case passed, so everything is correct. Basically here we have to call head dot next for the thing. Let me show what I mean by that. basically we are at 1, so we need, if we wanted to get this as our list, new reverse linked list, we have to call head dot next in a reverse function. So not head, because that will lead to recursive calls again and again. So for this we need to pass head dot next, so that when this function returns and give the value, it returns this as its output. I hope this is completely clear now. I hope this reversing and handling of the edges is also clear. This is quite simple, that we will just get the reverse linked list by our recursion. Recursion will take care of that thing, and we just need to like assign this next is now pointing to null, so we just need to assign it to here. So how we can do is that we can use this head. We will do that head dot next is equal to head. So now this will point to this, and we just need to remove this edge here, which is we are doing via here. And here we are calling our recursion function on h dot next, so that this sub linked list gets reversed first. Okay, now let's just quickly solve our last easy problem for this linked list problem. Okay, so now you will understand why I was telling that the reverse of a linked list is a very standard and a very important algorithm in linked list playlist, because that algorithm is used in various other problems such as this one, palindrome linked list. Basically what is palindrome is that the start, basically if we read from here and here, both of these are same. For example, a book, in a book, B double O K, it is not a palindrome because B double O K is not equal to K double O B. So that is not a palindrome. But whereas MADAM, madam, it is palindrome, because if we read it from left to right, it will be madam, and if we read it from right to left, it will also be madam. So let me just quickly show you exactly what I mean by this. In a number, let's say 121, it is a palindrome, because if you read it from here or here, it does not matter, it will be 121. But for example, 67, it is not a palindrome, because if you read it from here, it is 67, but if we read it from here, it is 76. So this is not a palindrome. So here in the question, it is asking that is the linked list a palindrome or not. If it is a palindrome, we will return true, otherwise we will return false. So how we can think of this is as like, as you can see here, this 1 2 2 1 is a palindrome, because if we read it from left to right, it is 1 2 2 1, and if we read it from right to left, it is 1 2 2 1. So it is a palindrome, so we will return true, and otherwise here we will return false, because 1 2 is not equal to 2 1. So it is very simple to code right here, because you can think of it as like, what we can do is we can reverse this and check if the reverse is equal to original. Let me show you what I am telling you. Let's say we have a sequence, let's say here this is the sequence, we know this is palindrome, right? So what we can do is, this is our original sequence. What we can do is we can make a function of reverse, which will reverse this original, and if the reverse of this will be 1 2 1, basically this one is here, this 2 is here, and this one is here, we are reversing the sequence. And here you can see that original is equal its reverse. So if this is true, then we will return that it is a palindrome, otherwise we will return false. Let me show you the different case where the palindrome is not there. Let's say this is 7. So in this case, the reverse of original will be 7 2 1. This 7 is here, 2, basically it is reversing of that sequence. Clearly here original is not equal to reverse, so we will return false, that this is not palindrome, so we will return false. So now we have quite comfortable with writing the reverse of a linked list. So what we can do is we can do something like, let me show you. If this is the linked list given to us, something like this, and we have to output that is it a palindrome or a not. Clearly you can see this is a palindrome, and this is our original linked list. So what we can do is we can use our reverse linked list function. This head is given, we can reverse this original linked list by our previous original reverse function which we defined, and this will return our new this will give new head which will be something like this. Now we can compare node by node by using a for loop or a while loop. We will compare this and this, we will compare this and this, we will compare this and this. If every node is equal, we will return true, otherwise we will return false. So let me just quickly dry run this one more time, because code is quite simple. We will copy that reverse of a linked list code which we already did. So it is hardly just 2-line code otherwise. So let me just quickly give you a dry run for this, what I mean by this. So let's just take it is 1, 2, 3, 4. So clearly this is not a palindrome. So what this will be our original list, and this head will be given to us. So what we will do is we will use this head, and as we know, we have already know how to reverse a linked list head. So we will pass it to here, and it will return new head. Basically reverse linked list head, it will be something like this. It will reverse all the edges of this and give us this new head. Now what we will do is we will we will compare this head and this new head, and we will go one by one. We will first check these two. If they are same, we will continue, and as clearly you can see they are not same, so we will break here and we will return false, that signifying this is not a palindrome sequence. Let me show you a true example also where it will return true. Let's say this is our original palindrome. This is our original palindrome. Now we will call reverse linked list function and store its new head here, reverse of this original. Now this will output something like this: 1, 3, 3, 1. So it will be pointing something like this. It will reverse its nodes, edges. So now we have this head and this head. Now we will again compare one by one. We will check this and this, are they same? Yes, they are same, so we will continue. We will compare this and this, are they same? Yes, they are same, so we will continue. Are they same? Yes, they are same, so we will continue. Are they same? Yes, they are same, so we will go ahead. And when they both reaches null, basically here also this is null, here also this is null. If they both reaches at the end at the same time, basically they have the same length, we will return true, otherwise we will return false. So let's just quickly write the code of that. Okay, so let me just copy our reverse linked list code because it is redundant here. We don't need to again and again write that. So I have just copied the reverse linked list code which we already did earlier. So I just copied that. Now I will make a new reverse linked list head and call this reverse function, reverse list function on head. Now this function will give me the reverse linked list. Basically the reverse of this will be 1, 2, 2, 1, same. So it is a palindrome, so we will return true. And if we pass this head to here, it will return 2 and 1, and the head will be at 2. So new head will be at 2 here for this. So now we have the reverse list and we have our normal list also in the head form. So now we just need to compare these two. While n underscore h is not equal to null, and head is not equal to null, we will run our while loop. If n underscore h is n underscore h dot value is not equal to head dot value, we will return false, signifying that in n underscore h there is 4 and in head dot value there is 1, so they are mismatching, so the reverse is not equal to original list, so we will return false, that this is not a palindromic sequence. Return false. In the end we will return true. But for that we just need to check one more thing, that is it that maybe this can also be the case, that let me show you what I am saying. uh, no, that can't be the case, because whenever we reverse a sequence, its length will remain same to the original, so it can't be occur that the new underscore head linked list length reaches to 0 but the original still have nodes. This can never be the case, because when we reverse 1 to 1, let's say its length is 3, when we reverse this, that length also remain 3. So there is no need to, there is can never be a case occur when the original linked list is of length 4 and our reverse becomes length 3 or 5. So this can never occur, so we just need to like return true only here. We we don't need to check any exceptional cases or edge cases here. Okay, so I just need to define this list node. uh, okay, so I am not like, if they both are same, if they both are different, then we will return false, but if they both are same we need to move to the next node to compare. Like basically, if this is same as this, we will need to move to the next to compare. So we need to move to the next to compare. Now we will compare this and this, then we will compare this and this, so I just need to traverse that. So I will do n underscore h is equal to n underscore h dot next, and head will be head dot next. I am just moving to the next node to compare. Okay, why this is the case here? Maybe our reverse linked list function is causing an issue here. It is returning true but we need to return false here. Okay. Why this is happening here? They will reach at the end at the same time, so there is no point in there. So what we can do is we can just use this. Okay, so why this issue is occurring is because when we make a new variable to store our original head here and we are changing this new variable here. In Java it is passed by reference, so whenever we are changing head 1, it is also changing our head also. So we need to create a hard copy for this in order to have this functionality. So here one extra need of hard work will also occur. So we have to create new nodes. Basically it will be a hard copy for that. List node. I am making a new list to compare, and I will reverse this new head to compare it with our original linked list. Let's make our traversal node, which will be at start, will be pointing to head 1 only. Okay, now we will make the hard copy of our original linked list, so that we can pass that into our reverse list function. How we can do is we can use a while loop, while and we have to also store our original head to somewhere. While x dot next, while x is not equal to null, what we will do is we will create new list node j. It will be new list node, which will take the value of the current original list. So that will be x dot value. Okay, now we will assign our head 1 dot next to this jth node, and we will traverse one further. So we will do x dot next is equal to x, and we will do head 1 dot next is equal to head 1 dot next. Now after this, our hard copy of the original linked list should happen. So basically what I am doing is I am making a new head here, initializing it with -1 node. So originally it will be just a single node with a value of -1. Then I am making these two to store and traverse in our linked list, so that our original head does not loses we don't lose our original head. So I am making these two variables. Then I am traversing into our original linked list, which is given to us by using this x variable. So till we are running this until x does not reaches to null. So we will run until we reaches null, and I am making a new node always while traveling, and then I am making these changes and this code to go further and further into the linked list and compare and add the new node into our new linked list which we are making. Now at last I will just pass this. I hope this should now work. Okay, so let me see why this error is occurring again and again. Mm, okay, so this reverse list node function is correct because we have already submitted it and it was passing all the test cases. So here there is no issues at all. But here we are making a new list node for our hard copy linked list which we will make, and we will reverse that later. These two are the variable to store the original head so that we do not loses that, and we needed those later, so we need to store them, and this is also for the traveling purposes, so we needed those. Now I am traveling in the x until x becomes null, because we will travel all these nodes until the x becomes null. So what we will do is we will make the new nodes side by side and assign those to the our new linked list which we are making, the hard copy one. I am making assigning them, and then I am going to the next of this. So here the x dot next is equal to x, but it should be x is equal to x dot next, because x will travel to the next node. It will be something like if here the x is and we need to go to the next, so it will be something like x changes to x dot next. So now x will changes from here to here, so it will be x is equal to x dot next. I was correct here, I just did this correctly, but I forget to do this correctly. So this was the only issue in the code which was occurring. So now every test case should pass. Yep, so everything is passing correctly. I hope you understand this. Let me just quickly do this again so that you get an idea of what was going on. So this was our original reverse linked list function which we already used and code, and I have already shown its algorithm to you earlier. Now for this I am making a new linked list node to traverse. As in Java the list node is passed by reference, so we have to make a complete hard copy of this linked list in order to reverse this, because if we do not do that, our original head which is used here is going to next or something or somewhere, so we needed to make a hard copy so we do not loses our head or our initial structure of the linked list which we originally had. So here I make the hard copy of this, then I am passing that hard copy's head into the reverse list function. Now this issue should not be there, because if now head changes, it will changes to the hard copies structure, not our original one. So now we can compare those two one by one and check if they are equal or not. If every node is equal, we will return true. Otherwise, at any point, if their value is not equal, we will return false, signifying that these are not a palindromic sequence. I hope you understand this question. So now every linked list question here that are easy is done. Okay, so let us see how many questions we have done. We have done 9 questions so far. Okay, so the pace is quite slow, but I am explaining everything in depth, so I think it is fine. Now we will move to the next question, which is two sum question. It is also a standard question of DSA. So let me just quickly erase this. Okay. Okay, so now this question is two-sum question. Here the given statement is given an array of integers nums and an integer target. Return indices of the two numbers such that they add up to target. Okay, so see this array. Here this array is like 2, 7, 11, 15, and the target is 9. So this 2 plus 7 is becoming our target, which is equal to 9, and we have to return the indices of the required number which sums up to the target. For example, here the target is 6, and this 2 plus 4 is becoming 6, and the indices of 2 is 1 and the indices of 4 is 2, so we are returning 1 comma 2. So this integer array which we have to return will surely be of size of 2, because we need to return two such numbers that sum up to target. Here it is simply that the given nums is 3 comma 3 and the target is 6, so this 3 plus 3 is 6, so we are returning 0 comma 1. And it is guaranteed in the question that there has to be one solution and exactly one solution. So there can never be the case that there occurs something like here in this array there is 5 comma 4. This can never occur because if the solution is there, it will be unique. So how can we approach this question? mm, okay, so we have to make array of size 2, so let's just quickly make that. This is guaranteed that it has to be there, so we will make the array of size 2. Okay. mm, there can be many brute force approaches to this question, but that will lead to order of n square time complexity. What we have to do is do it in order of n time complexity. So we have to do something that our answer comes only in one loop time complexity. Okay, and we have to return the indices, not the actual numbers which are summing up to 9. For example, we don't have to return 2 comma 7, but we have to return where they are occurring, like 0 comma 1. So let's just quickly see how we can approach this question. We have 2, 2, 7, 11 and 15, 11 and 15, and our target is 9. Okay, how we can approach this question is we can make a hash map here. Let's say a hash map which stores int and int data type. It will store int and int data type, where the first integer will be the value which we are storing, and the second one will be the index where that value occur. For example, if we traverse through the array, let's say we encounter 2, so in our hash map we will store something like 2 comma 0, because 2 is the value and 0 is the place where it is occurring, basically the index where it is occurring. We will do this, and it is a well known fact, it is a simple match that we have to find these two numbers which lead up to the target, something like this. We can do something like, we can do this equation will also be satisfied by these three triplets. Basically, a has to be equal to target minus b, then we have found our two pairs. Okay, so what we can do now is we can put, okay, so what we can have is something like 2. We can add that our to our map. 2 comma 0, we will add that to our map. Then we will go to 7, and we will add 7 comma 1 to the map. But before adding 7 comma 1 to our map, we will once check is t minus our current one, which is 7, is this number already present in our map or not. What will be this number exactly? As our target is 9, so this will be 9 minus 7, which is equal to 2. Now before adding 7 to our hash map, we will just check once is 2 already present in our hash map. So yes, it will it will search in hash map and find that the 2 is already occurring in our hash map, so it will return true. And we got that 2 is already there in the hash map, and now we are trying to add 7 in the hash map, but this target minus 7 becomes equal to 0. I hope I am clear what I am saying to you guys. Let me write the code so that you get more understanding of this. Let's make a hash map. It is a hash map of integer comma integer, where the first key will be the value, and the value, basically the key value pair, the key will be the value of nums, an element of nums, and the value of this map will be the will be the index where that element is occurring in our hash map. Okay, as I have already said that there are too many brute force approaches to do this question, as it is an easy question, so the brute force will also pretty well work in this type of scenario. But we are going in a order of n time complexity. Basically we will get our answer in just one loop, so I am running that loop here. Till the whole array size. Now see what I mean by this is, now we will check that if map dot contains key target minus nums of I. So what this means is, let's say we have added, wait, let me just write the code first and then I will explain you guys. At last I will return the answer, but this answer will never run, I am sure about this, because whenever we got our answer, which is this if statement, we will return, wait, let me just do this, answer of 0th will be map.get get no need to have this. I hope this should work. Yeah, I hope this should also submit. Okay, so the code is getting submitted and it is order of n time complexity, so there is no issue as such here. Okay, so now just I quickly tell you what is happening here is something like we are making a hash map where first is storing the element and the second number is storing the value, the index where that element is occurring. Then we are going to check all the elements of the num, so this is a for loop for the traversal. Then this if statement checks that if that map which we are building already contain target minus nums, basically something like if if that map if that map already has target minus nums of I, something like this, already has this. For this test case I am saying, because as you know in the map we already put this 2, so this 2 is there. Now this map is checking that if this map contains 2 or not. Yes, this contains 2, and as this contains 2 and our nums of I which is 7, due to this property here that the target minus second number which is this is equal to A, then this A plus B has to be equal to the target, so we got our required pair here. And now if we don't have to return this 2,7, we have to return the index where they are appearing. So that's why I am writing this thing, that the ANS of 0th put in that place map dot get target minus nums of I. Basically this will go to map dot get 2, and map dot get 2 will return the value of that key, value of 2, and in the value we are storing the index, so it will return 0th index, so it will return 0th. And in the second place we are just storing the second number which we got, that is 7 we got at nums of I is equal to 7, so we get 7 at the ith place, so we are just assigning this way. I hope this is pretty much clear to you guys, and this is the loop where we simply are putting the numbers. Let's say at first our map we are putting 2,0, so this is the statement which is putting that 2,0. Basically map dot put nums of 0 which is equal to 2,0. So now map have 2,0 already. Now this for loop will run again. Now if map dot contains key 9 minus nums of I which is equal to 7, this time it is returning 2, and yes, this is true that the map dot contains key 2, so this will run and this will returns 0 and this will give 1, and we got our required answer. I hope this dry run is clear to you guys. So yeah, this is quite simple question. Now let's just move to the next question. Okay, let's do some binary tree questions. Okay. Okay, let me just quickly erase these. Okay, so what we have to do is, given the root of a binary tree, we have to return the in order traversal of its nodes value. This is quite easy question because it is a standard question of the tree data structure. So what does the in order traversal mean? In order traversal means that first we go to the left, then we go to the root, then we go to the right. Basically, in order we are traversing left, middle, right. Left, middle, right. So, for example, if this is the tree, we have 1, 2, 3. So, what we have this left, there is nothing. So, we will go to first middle 1, then we go to the right, then we go to the left. So 1 3, then it is a middle, so 3 2, and our result will be 1 3 2. Let me just show you the in order traversal for this graph also. It is like, let me just build it. 1 2 3 4 5 6 7 4 5 6 7, we have 8 and we have 9. Okay, so now in order traversal basically means is, in order traversal basically means first we will go to the left, then we go to the middle, then we go to the right. So let's just quickly write the answer for this one. Okay, so we will start from the root. We will go to the left 2. Let me just use some other pen so that you get what I am trying to do. We go to 2. This also have the left, so we will go to the 4. Now this does not have any left, so we have reached our left part, so we will add 4 or print or add it into our list or whichever data type they are asking for. We will add this 4 to there. Now we will go back to the 2. Now this 2 has right, but first we have to like print it, so it will be 4 2 because left, middle. Now this is right, but for this right also we will first go to the left. So we will go to the 6 and we will print this 6, then we will print this 5, then we will go to the right and print this 7. Now the left part is already done. Now for this node we have done the left thing already, so we will go to the middle, which is equal to 1. Now we go to this 3th node. It does not have any left part, so now we have to print the middle part of this, which will be equal to 3. Now we go to the right of this, which is equal to 8, but we will not print it because it is middle. First we will go to the left part of this, which is equal to 9, then we will print 8. So this is the correct in order for this tree. Let me just check, are we doing this correctly? So the output we got is 4 2 6 5 4 2 6 5 7 1 3 9 7 1 3 9 8. Okay, so the output is correct. So our dry run was quite good. So now let me just show you how we can write the code for this. We have to return some array list, so let's just quickly make our array list. It will be the answer which we will be returning. We will return this. Okay, now let me just make a helper function because we will do this recursively. I will also try to explain you side by side how we are doing and how things are working internally. So let's just call our helper function. Helper function will surely take the root of our given tree and it will take the answer, because we have to store all the occurrences of this here. Okay, now let's just quickly make this helper function. This helper function do not need to return anything, because whatever the answer which we will be getting is getting by default stored into the answer, and we are passing this answer already in our function, so there is no need to return anything. So we will do public void our function name, then we will passing our root and answer, so we will make those tree node. Let's call it root, then we are passing our list. That is our answer. Okay, so now, as I already explained you that the in order traversal we will go like left, middle, right. So it is quite simple. What we have to do is, let's say if our root is equal to null, we will return, we will not add anything to our answer. We will simply go back to the previous function which we are calling. Let's say there is nothing at all. Let's say for example this case here there is no root at all, basically root is null, so we have to output nothing. So what we will do is we will pass this answer array and this null to our help function, and we will go like if root is equal to null, we will just return. We are not adding anything to the our answer, so the answer will also remain empty. So this is the base case of our recursion function. Now, as I have shown you that in order traversal goes something like left, middle, right. So in order traversal we will first go to the left. So how we can go to the left is we will call this help function recursively and pass root dot left here, and we will pass our answer here, and then we need our middle. Basically whenever we reach the middle, we will add that node to our answer array list. So we will add that ans dot add root to our answer, and now this will take care of the left part. This is our middle, basically root part, and now we will go to the right, left, middle, right. So we will call the right side of this. Okay, so I need to put root dot value here because our answer type is integer and the root data type is tree node, so we need the value of the tree node. So that is the case why the test case was failing. Yes, so now this is accepted, all the test cases are passing. This is quite easy question, this is just for the revision purposes, how we can traversal and what is the in order and pre-order of these things. So yeah, this is working. Now let's just go to our next tree question. Let me just quickly erase these. Okay, So in a symmetric tree, we have given a root of a binary tree. Check whether it is a mirror of itself, that is symmetric around its center. So we have to return true here because 1 is 1, 2 is matching with 2, 3 is matching with 3. Okay, here there is some trickiness going on. We have to match left with right, and we have to match left's right with right's left. Okay, 1 2 3 1 2 3. So this will return in false because 1 is the middle, 2 and 2 are matching, but 3 is at right here, but here the 3 is also at the right, but it has to be at the left in order to it being symmetric. So this is also a recursion type of question. Basically every tree questions of this sort is somehow recursions only, so there is no surprise in that. So how we can approach this question? mm, okay. Okay, so this thing is quite simple, that we have to pass this thing, this thing, and this thing. Now we have to match these two. Are those mirror images of each other or not? We will do something like this. We will go to the left, we will go to the right, we will call some function is similarity, which will check are they mirror images of each other or not. Now we have to think how we will make that function. We need to have some kind of comparison between the left and the right. So we need to make a helper function, and we need to pass the left of the root and right of the root to compare these two subtrees with respect to each other at each level. Okay, so what we can do is we can do write a base case that if root is equal null, we will just return true, because let's say if root is equal to null, we have the symmetric tree. So now we will call our helper function, which we have to make, and we will return it. It will return boolean data type, our answer basically. Return helper function, and we need to pass the two different child of this root so that we can compare those. So we will pass root dot left and root dot right, something like this. Let's just quickly make this helper function. It will be public, data type that it will return will be boolean, function name is helper, and the data type, the input which it is taking is pre-node. Something like this. Now we are in this helper function, and we need to complete this helper function which will recursively solve our solution. So we just need to complete this function for a single steps, rest all will be taken care by the recursion only. So let's say if we are at this level, basically the child of this, we have passed the root to be 1, and the root dot left currently have this node, and right currently have this node. So what we can do is, let's say if this left dot value and right dot value is not equal, we will return false, basically signifying that it is not a symmetry across the root. Because let's say if there is here is 2 and here is 3, then it is impossible that the rest of the tree will be symmetric. But before that, okay, let me just write that case, that if left dot val is not equal to right dot val, we will return false. Now before doing this value check, we need to do like a base case check also, because let's say if left here is null and right here is also null, then this left dot value will give error. Because let's say for example the cases where the root is 1 only and these two childs are not there, if they both are not there, so left will have null and right will have null. In this case also, when there is only single node present, that is 1 here, we need to return true, because 1 itself is the symmetry of the whole tree. So we need to return true in this case when the left child is null and the right child is also null. When both of them are null, then we have to return true. This will be our base case. But let's say suppose left child is there, for example the tree is something like 1 2 and here it is null, then the left will have 2 but the right will have null. In this case also it is impossible that it will lead to a symmetry, so we will return false in this case also, because in the left side there is one node but in the right side there is none, so we will return false in that case also. So if left is equal null but simultaneously our right is also null, then it is fine and we will return true. But if this is not the case, that this if condition will handle those cases where if the left is there but the right is not there, then we have to return false. Or else if right is present but the left is null, then also we have to like return false. So if left is equal to null, if left is equal to null and right is not equal to null, or left is not equal to null and right is equal null. Basically this is handling both of the cases where in one case left is null, right is there, and in the other case left is null and right is there. Basically vice versa if I misread that. Vice versa cases. Okay. In this case we will return false, signifying that no, our tree is not symmetric in this case. At last we will recursively call and go to deeper levels of this tree. We will call our helper function again. We will return helper of. Now what to pass here? Basically if we reach, let's say here, which is left and right, let's say this left is currently at pointing at 2 and this right is currently pointing to this second node. So now recursively what we have to check is, we have to check left dot left to right dot right. Basically this 3 is left dot left and this 3 is right dot right. So we need to compare these two. So we will compare helper of left dot left comma right dot right, something like this, and helper and this helper, this 4 is left dot right, and this 4 is right dot left. So we need to compare left dot right and right dot left. If these both also return true, then only we will say that our tree is symmetric. Let's suppose if any one of these return false, in if in any step symmetry breaks, the whole symmetry breaks. That's why I am putting and here and not or operator here. I hope this will get submitted and this is understood to you guys, because it is quite simple. For this question I do not even need to like explain you on the pad, so that was nice. Okay, it got accepted, fine, everything works for this question. Now let's just quickly try to solve this question, maximum depth of a binary tree. Let's just quickly remove this code of this question. Okay, so in this question we just have to return the height of this tree. For example, in this binary tree, the height, the maximum depth where this tree is going is 1 level, 2 level, 3 level. So we will return 3 for this. And for this one null 2, it will be something like 1 null 2. The height will be 2, because at level 1 we have 1th node, and at level 2 we have this second node. So we have to return 2 here. Okay, so we have to like return the maximum level or depth where this tree is going. So how we can approach this question is something like this. We have a binary tree and we have to return the maximum depth. So in for this binary tree we will return 3 as an answer. So how we can approach this question? We can use any kind of traversal, but the best traversal which goes level wise, we all known as level order traversal, also known as breadth first algorithm, BFS, or level order traversal. We can use this and we will get our answer, because level order traversal will go something like it will go firstly to this level 1, then to level 2, then to level 3, and at last we will return our level till which level we are going. When our children's become null, we will return the level which we got. Okay, so sorry. So how we can do this? So a breadth first algorithm or a simple BFS or level order traversal is quite standard traversal in a graph questions or a tree question. So for a BFS traversal we need a queue data structure, which will have these nodes as the data type for them. And what we will do is we will add these tree nodes. Let's say if we are at the root, we will add this to our queue. Then until and unless this queue will become empty, we will go to its children and add its children into the queue also. For example, we will first add this 3th, let's just make a queue, this will be our queue. We will first add 3 in the queue. We will go to, we will write a while loop something like this: while queue is not empty, we will run this like until and unless this queue becomes empty, we will run this while loop. And in this while loop we will extract this level. Let me show what I mean by this. We will like calculate the size of the queue then we will run a for loop here, for loop, so that whatever there is on the queue we can extract that. Then we will do like parent is equal to queue dot poll. By this, every node that is present in the queue will be extracted, and then we will go to this parents children. We will go to the left also, we will go to the right also, and we will add those children there. So what you can think is, in this level we will process all the parents of a particular level and extract those in this step. Then we will add their children to the next level for the processing in the next level. So it will be a level order kind of traversal, and we will maintain our ANS kind of data structure, which we will return at the end. At start it will be 0. Whenever a level is processed, we will do just ANS plus plus, and at last we will return this answer. When this while loop ends, we will return this answer, signifying all the levels have been processed and the finally queue is empty. That means there is no node or parents that have any children. So we reached our end and we will return our answer. I will explain this logic side by side writing the code of this question. So let me just explain this side by side. Firstly, our base case, that if root is equal null, that there is no tree at all, we will return 0, because let's say if there is no node at all, we will return 0, signifying that. And now as I have told you that for this that for BFS traversal we need a queue data structure. So we will make our data structure. For the data type, we will pass the node here because we will add nodes to this queue. And in Java, to make a queue, we use this. We make use of this linked list. We take the benefit of the linked list class to define our queue. Now at start we will just add our root, because of this condition that if root is equal to null, we will return 0. We have guaranteed that if anything get past this if while condition, then the root must be some node. So null case have been already tackled earlier, so there is no need to worry about that. So we will just add q.add our root. This is for sure due to our coding format that this root has to be some node, it cannot be null. Now as I have explained that our while loop condition will be something like, we will run our while loop until this queue becomes empty. So we will write while queue dot is empty, and while queue is empty means whenever queue gets empty, this condition will run. So we need when queue is not empty, so we will just negate the statement and we will get our appropriate condition. So now this while loop will run whenever the queue is not empty. Whenever the queue is not empty means there is some node to process, we will run this while loop and process that level. Now we need to get how many nodes are there in a particular level. For example, at start there is one node only where we added the root, then the size will be 1. For this level 2, the size of the queue will be 2 because it will have 9 and 20. And then for the level 3, the size of this queue will be 15 and 7, that will be 2. So I hope you get an idea what queue is storing. Basically queue is storing what is present in that particular level. At start there is only 3, we added 3, so at start there is only one parent, that is 3 on level 0. Then at level 1 we have 2 children, so in the next step where we define size, it will give 2 as an answer. queue dot size, something like this. Now we need to extract those nodes. For example, we do not remove, till now we do not remove this 3 from our queue. So now we will process all these parents of a particular level at a time, in a single time, for a single level, so that whenever we call their children, it is it is in consistent with the other parents, so that there is no mismatch between them, that one node is at level 0 and the other node is at level 1 and they both are at the queue. This can never be the case. If there is level 0 at the queue, all the nodes that are present in the level 0 will be there. If 9 is there, then the 20 has to be also there in the queue, because at a time level 0 nodes will be there, then level 1 nodes will be there, then level 2 nodes will be there, and similarly like that. Okay, before anything else, just make our answer data type, initializing it with 0, and we will return our answer. Basically this will store the height of the tree. So, and whenever this a particular level is processed, we will just do something like this, signifying that this level is processed, that level 0 is processed, now go to level 1, level 0 is processed, now go to level 1, and then whenever this runs again, level 1 is processed, go to level 2, and similarly like that we will get our height. So we will do something like this. Now we need to extract whatever parents are there in a queue. For example, at level 0 we have 3, so we will extract that 3 here. 3 node parent is equal to queue dot poll. So basically what poll does is it just extract the earliest added node and return, basically remove it from the queue. Now this 3 we extract this 3. Now we will call its children. We will add 9 and 20 to the queue, signifying we have already extracted 3. Now we will add 9 and 20. So if parent dot left is not equal to null, we will add that to our queue, signifying we have processed the parent. Now we are going to the children in the next iteration. Add parent dot left. Similarly for the right part, we will just copy this and we will just change left to right. Okay, now so what here happening is something like this. We extract 3 as a parent, then we are checking is parent dot left is null. If it is not null, we will add into the queue. If parent dot right is not equal to null, we will add it to the queue. Now 3 got removed from the queue, so now queue will be something like 9 and 20, which is signifying that we have reached level 2. So now we will calculate the size, which will give 2 as our answer, because we now have to process these 2 nodes. Then we will call this for loop, which will extract these one by one. First it will go to the 9 and it will extract that 9. 9 will get removed from the queue, and as it does not have any child, so it will just skip it. Now due to this for loop and this queue dot poll, this 20 will get extracted, and we will remove this 20 and we will go to its children, that if this parent dot left is not equal to null, we will add this 15 to our queue and we will add this 7 to our queue. Now this 9 and 20 will get removed and this 15 and 7 will be there in the queue, signifying we have reached level 3. I hope this BFS traversal is completely clear to you guys, because it's quite standard technique to solve these kind of question. It will reoccur in graphs questions also, and in many trees problem also in future. Okay, so I hope this gets submitted. Okay, there is some issue. Okay, we have to like initialize it like this. It was an issue of a syntax only. Yeah, so it gets submitted and everything seems correct. So here is the code once again. If you want to try on yourself, you can do that. Basically, what we are doing is, it is a simple breadth first traversal, breadth-wise traversal, or BFS, or whatever you say, level order traversal. It has so many names, but the core idea is simple. We are just traversing level by level. Okay, now let's go to this question, which is convert sorted array to binary search tree. Okay, so what we will have is a sorted binary. Oh, sorry, what we will have is an array that is sorted. This nums array that is sorted. What we have to do is, we have to return the root of the binary tree. So it is a binary search tree, where I hope you know that in a binary search tree. Okay, let me explain you here what a binary search tree actually means. Okay, so binary search tree is a tree which satisfies this property, that root and children. Here the left child is there, here the, okay, let me use some other wording for root. Let's call it head, for example, and this is right. So in a binary search tree, the property is that left child has to be smaller than the parent, and the right child has to be greater than the parent. For example, let's say 11, 9, and 12. This is a valid binary search tree, because left is smaller and the right is bigger than this parent. Also, it is quite clear that in this subtree also, this property should also be maintained. For example, in this subtree also, it cannot be the case that here it comes, let's say, 10. No, because this will fail this condition that left is smaller than its parent. No, so here it has to be something like 1. This is okay, because here the children is small, left children is smaller than the parent, and here it can occur, let's say there is something like 10 here. This can happen, because if you see, if you take this as a subtree, here these properties are getting satisfied, that the left is smaller than the parent and right is greater than the parent. This is satisfied, and in this subtree also this property is satisfied, that the left is smaller than the parent and right is bigger than the parent. Okay, I hope this binary search property, you know it quite well, that in the left side we put the smallest elements, and in the right side we put the bigger than the parent one. So it is quite clear that the smallest element that can occur, which will be at the leftmost part of the tree. Whatever the smallest will be, let's say a -100, it will has to be at the leftmost part of this subtree, and whatever will be the highest among all these will be at the rightmost part of this subtree. This is a quite simple properties, or let's say a simple conclusion that you can get from these two properties of a binary search tree, which is quite simple, that the biggest element will be at the rightmost part and the smallest one will be at the leftmost part, because we are putting the bigger at the right and smaller at the left at each level. So this has to be satisfied. Okay, so now it is given that we have a sorted array which is something like -10, -3, 0, 5 and 9. We have this array. Now what we have to do is we have to put it in a binary search tree format, and we have to return the root of the tree. This root of the tree we have to return as in our answer. So what we can add here is, we can add here -10 also, we can add here -3 also, we can add it here at 0 also, 5 also, 9 also. So how to decide this? Because let's say if we add -10 here, now if -3 comes, -3 is greater than -10, so we will put it here. Then we go to 0, this will also be greater than this, so it will result in some skewed type of tree which is like this. We don't want this as our answer, because we need height balanced binary tree, not some kind of binary tree. Because let's say if height balanced binary tree was not asked in the question, then this answer is also correct, because this is a valid binary search tree, but this is not a height balanced binary tree. Because height balanced means is that the difference between these two, left and right, should not be greater than 1. Here let's say the right height is 1 2 3 4 5. 1 2 3 4, so 4. The right height is 4, but the left height is 0. So here the difference is between left and right is 4, which is greater than 1. So this is not a height balance tree. Basically height balance tree is something like this, where the left part and the right part difference between those height is 1 or less than 1. Here let's say the right height is 1 2, right height is, sorry, it is left height, so the left height is 2, but the left, oh sorry, what I am saying is left height is 2 here, but the right height here is only 1. So here the difference between left minus right is 1. Now this is a balanced binary tree, because the left minus right is 1, which satisfies this property that it has to be at most 1. So how we can approach this question, like how we can convert our sorted array to a height balanced binary search tree? As I said you that if the height balanced tree was not asked, you can just put these in like this. We can just put the next element to the right of the parent, right of the parent, right of the parent, right of the parent, and this will get submitted, because there was no condition as such height balanced one. So but in this question it is given that we want to return height balanced one. So how to return this height balanced one? Let's just quickly copy that array, the sorted array. Here one thing you can analyze is, or basically deduct, that whatever here and whatever here, this can go to the left part and this can go to the right part, and this can be our root. It is quite simple to analyze. Basically if we have given a sorted array, we can do something like we can find the middle of that array, and whatever there is on left we will put on left, and whatever there is on right we will put that on the right side. Okay, so if we do something like this, then our tree will be something like this, that the 0 is our root, then we will go here and here. Now we have minus 10 and minus 3. We can treat this as a separate question only, basically a sub problem of our question. We will solve this via recursion, so we can pass this array or whatever left array, and we will use the same logic which we did in this bigger array, that now we have minus 10 and minus 3. Minus 10 is less than minus 3, so what we can do is we can put here minus 3 and here minus 10, and for this part it will be something like we can put 5 here and 9 here. Now this will be an appropriate height balanced binary search tree, because the left height is 1 and 2 and the right height is also 1 and 2, and the difference between left minus right is 0, which is satisfying that the height difference between those two must be at most 1, and here it is 0, which is like perfect. So we can submit this. Let's see what our resulted array looks like. Okay, we can return this also, because here these are saying that this is also accepted, so no need to worry about that, because it will take care of that itself. The recursion will take care of that, and this is for sure accepted in the answers. Okay, let me just write some bigger problems so that you can get a bigger idea how this recursion is happening. Okay, let's say the nums is this. We have this nums as our input, and we have to put it into a balanced binary search tree. How we can do is, basically I have made an example like this so that the index matches the element value. So now the index value is also the same as the element value, so you get better understanding how this index can get into the picture. Okay, so what is the length of this nums? So length of this is 1 2 3 4 5 6 7 8. Length of this is 8. What will be the middle? It will be 4, so it will be 0 1 2 3. Here it will be something somewhere here. So what we will do is we will pass these left one into one helper function and the right one into the other helper function, and we will make our middle as our root. Now in a helper function of the left, we can do something like we will maintain a start, middle and an end pointer, and will be pointing at 7 or 8 whatever, and will point to 7th index, and will point to the 7th, basically last index. In the left part we will keep start as same as earlier, and we will go to end. Basically the end of the left one be middle minus 1, and this will be our root, and for the right one we will call something like starting will be middle plus 1, and ending will remain same for the right part. I hope now the picture is getting clearer to you. Now we will again break this, again break this, again break these, again break these. Basically recursion will take care of these. Now I have explained you how the splitting is working here. The left part is breaking between s to m minus 1, and the right part is breaking into m plus 1 to end, and our middle part is becoming the root of that tree. Okay, So let's just try to solve this question. As it will as it is a question of a recursion, we will need to make a helper function so that our work get easier. Let's just make a helper function. And this helper function will also return our tree node. Basically that will be the answer, the root which we need to return. We will just return this, and in this helper function what we will have is start and end and our array, basically our original array. So what we will have is, we have start, we have ending index, and we have our nums array which we have. Now we will return this helper and we will call this helper function to like convert into the balanced binary search tree for the whole array. For the whole array, the starting will be at the 0th index and the ending index will be at nums dot length minus 1, and we will pass our array into the function also. Now we will calculate the middle element. As I have discussed that we need to have this middle element, which we will make it into our root of our binary search tree. So what we will do is, we will calculate the middle element, that will be start plus end minus start by 2. This is the way to calculate the middle of a array. We can also do start plus end by 2, that is also fine, but by doing this we handle some edge cases where the start plus edge goes out of the integers boundaries, integers range basically. Okay, now we have our middle element. Now we have to make this middle element our root. So how we can make this middle element as our root is, we will make a new node root, that will be new tree node, and have the value of this middle, basically this middle, it will have the value of the middle index. Basically middle is storing the index and we have to have the node value here, so we will call array of middle, so it will be nums of mid. By doing this we get our root, which will get initialized to 0. Now we need to attach this to left part and the right part. So how we can do that is, like, we can do root dot left is equal to, we will call this helper function, and as this is the left part of our root, as I have said, we will call start till mid minus 1, the left part of our segment. So we will call start comma middle minus 1 comma nums. Now this will take care of the left part. Similarly we will attach the right part to the root, and the right boundary will be starting from middle plus 1, middle plus 1, starting from 4th till end, so it will be mid plus 1 to end. So our start will be mid plus 1 and ending will be end only, and we will return our original root. Let's just see how this is working. Okay, there is some kind of issue here occurring in this part. Start middle minus 1. Hmm. Okay, we have to have a base case also, that if start is greater than end, that in some case our start becomes greater than the end. Basically our left part goes to the right and our right goes to the left. We have done, so we will return null. In that case we will return null. Yep, so it get accepted and everything is working. I hope this question is quite clear to you guys. It is quite standard example of binary search tree and how binary search algorithms works, because in that also we search, we get the middle element, then we compare, are we going to the left part or are we going to the right part. For the left part our range is start to middle minus 1, and for the right part our range is mid plus 1 to the end. We are doing that only. Here there is some novelty of this tree node and how this works in this regard. That also I have explained, that we will make our middle root and we will call this left part to attach root dot left to that and root dot right to the right. And as this helper function will only return the tree node only, so this root dot left which required tree node to get assigned, this helper function is also returning that tree node only. So we are good to go and use this code as our example. For this we are calling whole nums array, then we are dividing. Basically it is something like a divide and conqueror algorithm also. So it is a intersection of divide and conqueror algorithm, then our binary search tree and the height balanced binary search tree. What exactly you mean by that? What are the properties satisfied by these trees, and our binary search algorithm on our sorted array. So it is a combination of these three. I hope this is completely clear to you guys. Okay, now let's just quickly try to solve these two questions also, because only these two questions are left for these two. Okay, let's just quickly remove our code. Given the root of a binary tree, invert the tree and return its root. So we have a binary tree of something like this sort. What we have to do is we have to invert it. So 4 is 4, but here the left is 2, but here the right is at the 2. So we have to invert level wise. So if there is at a level there is 2 comma 7, we have to make it 7 comma 2. If at a level there is 1 3 6 9, we have to make 9 6 3 9. We have to invert that basically. Okay, this is also, as we just did a level order traversal or a breadth first traversal BFS. So this is quite similar to that, because we will go level wise. We will go to level 1, we will go to level 2, we will go to level 3, and we will invert those levels only. We will invert at that level only. We will go to level 1, then level 2, and at when we reach the level 2 we will invert these two values. Okay, So as I have just explained how to solve and how to traverse in a breadth first setting, so I will not explain that again and again. So what we will do is I will write the code simultaneously. I will try to explain my approach also. Okay. So if the root, our base case as always, that if root is equal to null, we will return null only. So this is quite easy because by handling that edge case at the start only, you just focus on the rest of the questions itself, rest of the problem itself. Then there is no need to like again think that what will happen if the root is null or something like that. Okay. Okay. Now, as you know, we have to do a level order traversal, and in that we need a queue data structure. So let's just quickly make that. In previous question also we use tree node data type here. So here also we will use tree node data type. And in Java we use this syntax to make queue. Basically we took advantage of how linked list is implemented internally, which is quite similar to queue, because in data structures algorithm classes, you know, we can implement a queue using a linked list. Here in Java they are using that only. So we will define our queue with the syntax something like this. At start in the queue we will add our root, because root has to be some value, because root is equal to null. We have already tackled that. So we will add the root to our queue. And as in the previous question also, I have said that we will be in a while loop until and unless our queue becomes empty. Here also the condition will be same, that we will be in a while loop. We will do the iteration as long as our queue has some elements in it to process. While queue dot is not empty, because queue is empty and we are negating that statement. So ultimately this statement means while queue is not empty. We will run this loop, and as soon as we have reached that the queue is empty, we will just return our root only. Because when we are returning our answer, here the root will always remain same, because root will have a single value. There is no other node to revert it with. So we will return our original root only. We will return 4 4 2 2. The real problem arrives internally, because we have to change the left to the right. Basically, see, the left of 4 is 2, here the left of 4 is 7, and here the right of 4 is 7, but there the right of 4 is 2. So we have to return internally, but we have to ultimately return the root only. So that's why I am returning the root, because here there is no other node to invert it with. So I am inverting it that way. Now I will extract the node one by one. Let's say tree node. Our node, let's call it parent. It will be q dot poll. So we have extracted our node. So we have extracted our 4. Now what we have to do is we have to make left to right, because here the left of 4 is 2, but in the answer which we have to return, the 2 is at the right. So what we have to do is we have to shift this edge, we have to shift this 4 to 2 edge which is at the left to right of 4. So what we will do is we will make a new temporary variable as we are doing some kind of a swapping. We will swap this 2 and 7. We will swap these two. We will swap this A to B and this B to A. So we will need a swapping, and for a swapping we need a third variable, because swapping is like quite simple, and previously I have also done this, so I hope you know that we need a third variable to do a swapping. Let's call it a temporary variable. So let's just store the left part to this temporary variable, that will be parent dot left. Now as we have our parent dot left stored in a temporary variable, we will just put the right part into the left. So what we will do is we will do parent dot left is equal to parent dot right, and parent dot right is equal to our temporary variable which we stored, and there the value is parent dot left. So after this we have done our swapping. So after this code, what our result will look like, something like this. Our 4 will be there, then in 4 the left one was 2, but now the left one will be the 7, because we have swapped 2 with the 7. And similarly, originally on the right part there was 7, but now as we have done our swapping, there will be 2 attached to its right because of this swapping. Now we will go to the children of these nodes, the left and the right, and we will do the same steps again and again, because this while loop will do that. That while loop will handle that thing. So if parent dot left is not equal to null, we will add that to our queue. Similarly, if parent dot right is not equal to null, we will add that right part to our queue. And that's it. The code is completed. It is quite simple code. I have already explained the BFS, and I have tried to explain this also. There is nothing in this code. We are just swapping the left part to the right and the right to the left, swapping between two nodes we are doing, and then we are going to the next level. That's all. So it gets submitted, all the test case passed, 100% success rate. Now only the last question is left. Okay, so for this question we have to find the diameter of the tree. Basically diameter is defined as the length of a path between two nodes that have the longest path between any two nodes in a tree. For example, in this tree the diameter will be from 4 to 1 3, and the edges between them is 1 2 3, so the diameter will be 3. One thing to note that is, in diameter always 1 will be there. The root node will always be there in the diameter length calculation. Okay, so how we can approach this question, because in this question we need the maximum diameter, or let's say width of the tree. So let's just move to the iPad here. Okay, so here we need to return 3, which is the diameter of this tree. Now this is the diameter they are asking for. One thing you can notice here is that it will be something like left height plus right height, something like that, and these left height and the right height of the tree will be the maximum left height that can occur, and this will be the maximum right right hand side height that can occur in a tree. For example, let's see the left part of this root. Here the left part only is connected to the 3, which is giving the right height maximum to be equal to 1, because right hand is 1. Basically depth wise I am saying that. And similarly in the in the left hand side, the maximum depth where this tree is going left wise is 1 2 2. And at last we will return max left height plus max right height, and we will store it in some max variable, and we will get our answer. So our question reduces into something simpler, that is, we only need to find the maximum left depth and the maximum right depth of the tree, and we will just return the addition of those. And we can make a global variable max and store that and update that accordingly as we traverse, and it will follow a DFS kind of algorithm, and we will maintain a maximum variable that will be the global variable to store our answer, and at last we will return this max. It will be integer data type, and I will also try to explain you more about this question as I write the code, so that you can get better understanding of this. Okay, so let's just make our global variable int max. Let's initialize it to 0 first. Now we will make a helper function that, let's say, will return integer, let's say, and it will contain the maximum depth of the tree. Basically maximum depth, what I mean by that is whether the maximum depth is occurring via the left or the right. Basically this function for this example will return 2 because the depth of this tree is 2, maximum depth is 2 here, so it will return this 2. We can also skip this part because we don't need the depth, but it is quite good to have, because in this way we are solving kind of two question in one question. That is, we are returning the maximum depth also, and we will return the maximum width also, that is also known as diameter in this question. Okay, so int depth, let's make our helper function, and we will pass our root node into it. That will be enough for now, because we are maintaining a maximum variable here for the max diameter, and the depth will be the return type of this help function, so we don't need to maintain or define that in a function itself. At last we will return this max, because that's what the question is asking. Let's just quickly make our helper function. It will be public. Data type that it will return will be integer, so public int helper function, and we are passing root. Now our base case, as always in these type of question, is simple, that if our root is equal to null, we will return 0. That if root is equal null, we will return 0. Basically this function will return the maximum depth or the height of the tree, and you can think of this as, if the tree does not have any node itself, it will return 0 only, because there is nothing to calculate, there is no height. Y-axis of this tree is 0, so we will return 0 if root approaches to null. Now we will calculate our maximum left height, and we will calculate our maximum right height, that I have explained you here in this, that we need this left height maximum and the right height maximum. The left height maximum will be simple enough, that it will be help root dot left and maximum right height will be help root dot right, because this function is returning the depth of the subtree. If we call this help function on root, it will return the maximum height of the whole tree. But if we are calling it here that the left height is equal to help root dot left, it will return the maximum height of the left subtree, and right similarly root dot right will return the right maximum height that is there in that subtree. Okay, now we need to update our max function, and as I have already defined, it will be the sum of these two. So let's just quickly update our max function. Max will be math dot max of max comma L underscore h plus right underscore h. Basically maximum left height possible and the maximum right height possible. It will be the sum of these two, and we will store the maximum of these two into the max function. Basically we are, by doing this, we will make sure that our max variable have the maximum of L underscore h plus R underscore h wherever that thing occurred. Okay. Now at last we will return this, what is the maximum height of the tree, and in order to do that, basically in order to return the maximum depth of the tree, which is here in this case is 2, it is simple, the maximum of left height or right height plus 1. So it will be something like 1 plus math dot max of L underscore h left height or right height. Yup, it gets accepted. I hope all the test cases pass for this question. Yeah, so all the test cases are also passing. Basically this function return 1 plus mat dot max L underscore h comma R underscore h is basically saying that the depth of this tree will be 1, that will be the root node which we are calculating in this calculation, will be the 1 plus left height or right height, maximum of these two, because after this calculation our L underscore h will have 2 in it and our R underscore h will have 1 in it, and at last we will return the maximum height, which will be the max of 1 comma 2, which will be the left height, that is 2. We will add this 1 into it because of this root node calculation, and we will return this maximum depth, that will also return 3 in this case. So in this case the diameter is also 3 and the maximum height is also 3, because in diameter calculation 1 plus 2 is occurring in this case, because as I said the L underscore h is 2 and R underscore h is 1, so here 2 plus 1 is occurring in this case, but here it is occurring like 2 comma 1 mat dot max of 2 comma 1, which will return 2, and we are doing one addition for this root calculation, that will return 3. In this case the depth and the width of the tree is same, so we will return this only. So yeah, this got accepted. Let's just quickly move to the next question. Okay, now the next easy question that remains is this, so let's just quickly try to solve this. I am just quickly removing this. Okay, given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it was inserted in order. You must write an algorithm with order of log n time complexity. Whenever there is sorted array given and time complexity they are asking is log n, it is clear that we have to use binary search algorithm, and I hope this is quite universal algorithm, so I don't need to explain that on the tab. So I hope this is clear. So let's just quickly write that algorithm. It will be a good revision for me also. So let's just quickly write that. Let's just define the length of the array. Okay, now let's just define the start and end of this, because in all the binary search algorithm we need a starting index and the ending index. By doing that, we will try to divide the windows into smaller and smaller arrays. Ending will be n minus 1 because of the 0th index in Java. And now we will write a while loop while start is less than end. Whenever the start is less than end, we will find the middle element, because in this binary search algorithm we always use start, mid and end pointers to shorten the subarray. And mid calculation is simple, that the start plus end divided by 2, you can do that also. And also for some edge cases that result in integer overflow, we try to use this also, because whenever we do start plus end, it can lead to integer overflow. So we kind of define this way, that end minus start by 2. Okay, now I hope you know the if conditions that occur in binary search algorithm, that if ARR of mid is equal our target, we will simply return mid. We will simply return mid okay, I don't know why this bracket plays here. Okay, now else if ARR of mid is less than our target. Basically our mid calculation thing is at the right of the target, so we need to search at the left sub array, so we need to modify end of the array. So we will do end is equal to mid minus 1, and in else case we will do modify our s, in that case mid plus, because in else case the only case that is remaining is when our target is greater than our ARR of mid. Basically our target is at the right side, so we need to like increase our starting pointer so that our mid calculation adjusted into the more right side of the array to find that target. And at last we will return this, we will return minus 1, which will signify that we have not find any element in the array. Okay, there is some issue occurring. I have returned mid here. Start plus end minus start by 2, that is also correct. Our end calculation is also correct. Our while loop calculation is also correct. Expected was 2 here. There is some issue occurring. Maybe I have reversed these conditions, so let me just quickly just check, is this correct? Okay, now this calculation is correct. Now one thing I noticed here is that basically in the test case, let me just quickly run this and show that thing to you also, that if the target is not there, basically in this nums target is not there, so we should return minus 1. But no, here in the question it is asking that if it has to be inserted in order, then at what index it will be placed. So if say in this nums the target 2 is not there, we can clearly see that, so we don't have to return -1, but the position where it will have been placed if it was there. So let's just put our 2 in this sorted array, then our array will be something like 1 comma 2 comma 3 comma 5 comma 6. So we will have to return 1, because at in that case our 2 will be at the position of the 1th index. Similarly, here also the target is 7, which is not present in our nums. So if it was there in our nums, it will be at the last index after 6. So we have to return 0, 1, 2, 3, 4, fourth index. Yes, so that is correct. So we have to return that index. So at last we have to return basically our starting index where that start has landed. That will work, I guess. Okay, maybe right is the correct thing that they are asking. Basically right meaning our end basically. Okay, what about our mid that we calculated? Here this start should work, I guess. Maybe there is some issue. Yeah, so now this code works correctly, I guess it will submit. Okay, let me just try to explain why returning our start index is the correct, is the giving our correct answer for this type of question. Okay, so what is our array here? Here the array is 1 3 5 comma 6, 1 3 5 6. Our array is 1 3 5 6 and our target is 2. So this is quite clear that if this 2 was there in our array, it will be at this position, it will be at this position, and we will return this 1th index as our answer. So let's just quickly dry run this question and try to do binary search algorithm via pen and paper, and I will give you reasons why returning s at the end will give the correct answer for this question. Okay, so for this our n is basically 4, so our end will be basically 3, because end calculation we are using n minus 1. So our start plus end by 2 will give 0 plus 3 by 2, which is equal to 1.5. Basically that will be equal to 1. So our middle will be at here. This will be our mid. Here will be our start. Here it will be our end. Now see, so basically starting index is 0, ending index is at 3, and our middle calculation for this iteration is at 1. You can also do at 2 also, this will give the same answer. So let me just quickly try to solve you. Here the start is less than equal to end, this condition is getting satisfied, so we will go to we will run our while loop and mid will be calculated. Now in our first if condition, it is something like, is the target equal to our ARR of mid? Let if target is equal our ARR of mid. So clearly this is not the case, because our target is not present in the ARR itself, so it will always not run, it will always not run, this if condition will not run, because our ARR of mid is basically 3, our ARR of 1 is equal to 3. So 2 is not equal to 3, so this if condition will not run. Now the second if condition is that if target is less than our ARR of mid. If this is the case, that if target is less than ARR of mid, that if target is less than ARR of mid, so what we will do is we will search in the left part. So do we will do end is equal to mid minus 1, because we have to search on the left side of the thing. So we will do end minus 1, and this will run, and we will store our end calculation will change, and it will be something like end is equal to mid minus 1. That will be end is equal to 1 minus 1. This will result in 0. I hope this is clear. Now our end is 0, our start is 0, and our mid is still at 1. Now, as in the while loop we have written something like s less than equal to end, here end is less than equal to start, or start is less than equal to end. So this while loop will run again. This if condition will false, because now ARR of mid calculation will be also 0, because end is 0, start is 0. So when we do start plus end by 2, 0 plus 0 by 2, it will still give 0 as an answer. Now end, start and mid all are 0. So what will be the ARR of 0? ARR of 0 will be 1. ARR of 0 is 1. So now this if condition will run, that if our ARR of mid is less than our target, and this condition will run because ARR of mid is 1 and our target is 2, so this condition will run. And in this condition we are doing that s is equal to mid plus 1. Our mid was 0 at start, so it will be 0 plus 1, which will be equal to 1. Now see our 3 variable. Our start is 1, and our mid will be 0, and our end will be 0. Now in this condition it is clear that our start is not less than equal to our end, because start is at 1 but our end is at 0. Now this if condition will fail, the while condition will fail, and we will not run our while loop. So now what you see is that our start is storing this 1th variable, 1th index, and you can clearly see when our target is 2, which is not present in the array itself, then our answer will be at 1th index. So how I think of this question always is something like this. Whenever we are doing a binary search algorithm, our start and end look something like this, and our middle element is somewhere here. Now whenever we find our middle element, it is quite simple that it is in ARR of mid, so we return mid as an index. But whenever our while loop is unable to give the answer, that means only one thing, that the element which we are searching is not present in the array, so we will return -1 in that case. But this while loop always run when s is less than equal to end. So this while loop will only end when our start becomes greater than end, something like this, and we have to place our element between end and start. So what I do at last is I return s or end. Now how to decide which element, which variable to return? So you can just do trial and error. You can return start first and end again if the test cases is failing, because generally answer lies within either the answer is start or the end, or end plus 1 or start plus 1, or some combination of these two. So you can just do trial and error. The answer will always be somewhere among these. So I hope this is quite clear. I have also explained the algorithm behind this, so I hope this is now completely clear. This was submitting, all the test cases were passing. Yeah. So now let's just quickly solve the next question, that is this question. Let me just quickly remove this. Okay, so this is again a classic question of dynamic programming, this time climbing stairs. So you are climbing a stair, it takes n steps to reach the top. Each time you can either climb one step or a two step. In how many distinct ways you can climb to the top? So this is a dynamic programming question. This is not a greedy algorithm which we can apply here, as there is no max or minimum also. So greedy approaches will fall in this type of question. So let me just quickly write the setting of the question. So we are climbing a stair. Let's say this is when the n is equal to 0, and this is when n is equal to 1, and this is when n is equal to 2, and in this case the n is 1 2 3, n is equal to 3. Okay, so these are the cases which I will be taking to explain the approach of this question. So let's say when our n is equal to 0, so how many approaches you can go to the last of this array? It takes n step to reach the top. Basically, how many ways you can reach to the top when our n is 0? It is quite simple that only approach is while standing here, then our start and ending both position are same, so only approach is n, is our answer will be 1 in this case, because there is only one way, that is by doing nothing and standing still. This is still a way, so our answer will be 1. Now in this case, when our n is equal to 1, how many ways are there when you stand here to reach here? It is quite simple that we can take only one step or two step. So to reach at the top, we can only take one step, because there is no stair to do our second step. So our answer here will also be 1. There is only a single approach to do a one step, and our answer will be 1 in this case also. Now for n is equal to 2, when our n is equal to 2 and we are at here, how many steps are possible, how many ways are there to reach the top? Okay, so one can do something like, okay, so this is n is equal to 3th case, so let me just remove one stair. Oh, sorry. Okay, let me just quickly draw this again. Okay, so in this case, when we are standing at the ground, what are the ways to reach at the top? What will be the answer in this case? It is quite clear that one can do one step. This is one possible way. So this is one possible way, and there is one another possible way, that this person directly takes 2 step and reaches at the top. That will be 1 step again. So in this case, our answer will be 2 when our n is equal to 2. Now for n is equal to 3. Now for n is equal to 3, when we are standing here, how many approaches will be there to reach at the top? First approach will be simply to take one step. This is one way to do this, so our answer will be 1. But there are more ways to do that also. So what this person can do is, it can jump to this by taking 2 steps and then take 1 step to reach here. This is another way to do things. But there is one more way to do this, that if that person first do 1 step and then do 2 steps, So this is again one approach. So in this case our answer will be 3. Okay, so currently it is seeing like when n is equal to 1 we are returning 1, when n is equal to 2 we are returning 2, when n is equal to 3 we are returning 3. But when our n will increase to 4 or 5 or let's say 10, 12, the answer will go to more number of ways than we can think. So to do this kind of question, what you can think here is that, let's just say somehow we know how many ways it will take to reach here. We know how many ways are there possible till I minus 2 and I minus 1th position. We know that. Let's say we know that. So what will be the case to reach the ith? How many ways will be there to reach at the ith stair? It will be quite simple that let's call these ways that somehow we know that to reach here, this is our ith, and this will be I minus 2 and this is I minus 1, and we know this how many ways are there to reach I minus 2th stair. We know that, and we also know that how many ways are there to reach till I minus 1th step. We know these two ways. Let's suppose we know this. Now how many steps will be, how many ways will be there to reach ith step? It is quite easy that it will be sum of ways of ith will be sum of these two. Whatever ways we are possible to reach I minus 2th stair and whatever ways are there to reach I minus 1th stair, we can either jump to 2 here or do something like this here. So it is quite clear that we can add these number of ways to get our ith answer. In DP we always have to think in a sub problem kind of scenarios where we break our problems into sub problems, that we need to find the answer for the nth stair, but we break it to the ith one and try to write a recursion formula or a iterative formula that we can use again and again. So this is our main DP sub problem formula question, because here this ith can be equal to n. This is just a variable, but thing is that this will solve the problem, that is the sub problem for the ith also. When I put I is equal to 2, it will solve for the 2 stair. When I put I is equal to 3, this will solve for the 3 stairs, and similarly it will fill our array, and at last I will solve for dp of nth and it will solve for that also. It is a bottom up dp approach that I am trying to tell you here. I can go more depth to it, but we have to do more medium level and hard level question on this DP playlist also. So I will try to explain that more in depth there, that what I mean by the sub problem approach, that this is a sub problem approach. We are breaking our bigger nth problem into sub problem, and we are trying to find a formula that we can use and update that again and again, and we can find those iths using I minus 1 or I minus 2 or some kind of formula there. It can also be possible that in some cases it will be I minus arr of I or some kind of max of these two. It is always something like this, that whenever we try to define a formula, it is a combination of some previous already done iterations. Let me just write the code for this so that you can get better understanding of this. What I mean by that is, let's just define our dp. It will be new int dp of n plus 1. Why n plus 1 is because in Java the DP is the integer array starts from 0 to n, so we need n plus 1 in order to calculate that nth. Because let's say we need to find the answer for n is equal to 3, but let's say if we define our integer array to n only, that is 3, we will only be able to fill 0, 1 and 2. We were unable to get the answer for the third stair, so we need to do this n plus 1 in order to take care of that thing. Now at start we will initialize our DP with the base case, and a base case is quite simple, that when n is equal to 0, I have already explained you that when our n is equal to 0 there is only one way, so our DP of 0th will be 1 and our DP of 1th will be also be 1, because there is only one way to take one step from here to here if their n is equal to 1. So let's just do that. DP of 0 is equal to 1. You can think of this as sub problems, that let's say our n was 0, then the answer was DP of 0, that is 1. Now let's say what will be the DP of 1 when there is one stair, then also the answer is 1, that the user will take one step at a time and it is the only possible way to reach at the top, so we will return 1 in that case also. Okay, now we will do a bottom up approach, that for int I equal, basically 0 is already done, 1 is already done. And why I have defined these two at the start is because in the formula for the DP of ith we need I minus 2 and I minus 1. So if I start from I is equal to 2, then I need DP of 0 and DP of 1 to calculate DP of 2. That's why it is starting from I minus 2 and I minus 1, and for the for loop I will start from 2 to end. Okay, now let's just write that formula of the sub problem formula, that DP of I is equal to DP of I minus 2 plus DP of I minus 1. And at last we have to return the answer for the nth step, so we will return DP of nth. We will return this. Basically this DP is storing the answer for all these ith stair. Yes, so this get accepted. I don't know why our approach is very bad here, but this is quite standard approach, and this is a optimal time complexity approach also. Let me just analyze it and find and show it to you that this is the optimal solution only. Okay, so we are doing dynamic programming comma recursions, but this is not the case because we are not making a stack. Okay, these suggestions are for, let's say, a more optimal approach where we don't even need this int of DP, this array. We can use current, we can maintain a pointers basically to have the state, have the answer in, say, a variable known as answer1, answer2, and our current step approach. So we can use that also. Basically they are saying that store this one in, let me just try to do that also here so that you get an idea. Let's just make this to step 1, and let's just make this to step 2. Okay, now let's just define a current also. current variable also. This will store the answer that we needed, so we have to return this current, and this current will be equal to S1 plus S2. Then our S1 will become current and our S2 will become S1. So we are just moving one step at a time. Okay, so our code failed, but more or like this is okay. So what I am doing here is this step is wrong. This step will go after this step, because we need to store our previous 2 to our S1. If we do this at start, then S2 will also store current. That is wrong. So I hope this will now work. Yeah, so this now works. This is just a base case. When our n is equal to 1, we have to return 0. So let's just quickly write that if n is equal 1, we will return 1. Okay, we don't even need this. We will just update this current from 0 to 1. Then also this should work. Yeah, so this is now submitting, and this beats all of those. But again, the time complexity is still order of n. In the previous one which I showed that to you, there also the time complexity was order of n only. So by doing this, we are only reducing the space complexity from order of n to order of 1, because in previous approach we were maintaining a dp array to store our answer, but we don't need all the answer. We don't need the answer for the sub problems. We only need the answer for the last one. So we reduce that by using these variable to store only I minus 2 and I minus 1 and our current state. So basically you can think this S1 as I minus 1 and this S2 as I minus 2 and our current as I. So this formula is same, that our ways of I is equal to ways of I minus 1 plus ways of I minus 2, and we are updating these as we go to next year. Basically, when we go to the next year after calculating the current, the second last one become the last, and our last will become the current. We are moving one stair ahead. We are shifting these variables one step ahead. So now all the easy questions are done, I guess. All the easy questions I believe are done. These are done. This is also done. We have done move zeros also, majority element also. So yeah, now all the easy questions are done. So we will move to the medium questions now. Let's just see which medium question we can solve. We have till now done 23 questions, and now we will quickly do all the medium question also, and that will reduce the chunk of the problems that we are trying to solve in this playlist.